essencialmente a atualização da nota rodoviária número 31, que é um documento que foi produzido já há vários anos. E como nós sabemos, estes documentos não são documentos estáticos, devem ser atualizados de tempos em tempos para poderem acomodar as novas realidades que o mundo vive. É por isso que estamos aqui, porque Moçambique foi um dos países que foi escolhido para acolher alguns ensaios com vista à atualização deste documento, e por essa razão mesmo foi escolhida também para a disseminação dos resultados destes ensaios e os impactos que os mesmos vão trazer no processo de atualização deste documento. Então, espero que nós todos estejamos atentos àquilo que são as informações que vão ser partilhadas pela equipa da TRL, que foi encarregue de realizar este trabalho e que também contou com a participação de alguns técnicos moçambicanos aqui presentes neste processo. Este é um workshop que vai nos levar 2 dias. 2 dias, o primeiro dia vai ser um full day e o segundo dia, que vai ser o dia da manhã, vamos dizer que vai ser um half day, porque o programa dá-nos a indicação de que vamos terminar por volta das 14 horas da manhã. Vamos olhar para este documento na componente de pavimentos flexíveis e na componente de pavimentos rígidos. É claro que aqui em Moçambique não temos muita cultura de pavimentos rígidos, mas com a questão das mudanças climáticas, provavelmente vamos ter que embarcar para este tipo de pavimentos. Temos algumas secções com pavimentos rígidos e provavelmente vamos ter que embarcar para pavimentos rígidos para algumas áreas em que está mais do que provado que os pavimentos flexíveis não são eficientes para aquilo que é o desempenho desejado dos nossos pavimentos. Tendo dito isto, vou convidar ao representante da HVT para fazer a sua intervenção. E, mais uma vez, muito obrigado pela vossa presença.
Good morning, everybody. I acknowledge the presence of the Deputy Director General and the Director of Planning, the delegation, and other ANE and stakeholders in the private sector and other institutions. My name is Francis Tangare, and I am representing the team leader of the High Volume Transport Applied Research. Just to give a background of what the HVT or High Volume Transport Applied Research is about. This is a program which is funded by UK aid from the UK government, and it is implemented by DT Global. The objective of this program is to update vital transport research that reduces poverty and develops economies. Furthermore, the aim of the program is also to make transport safer, greener, more affordable, accessible, and inclusive in low-income countries. We recognize the need that transport is key to the economic development in low-income countries, and the question we need to ask ourselves is, how can we help to make life better for the people living in low-income countries by developing better transport systems and make it better for all of us? So we also need to understand that there is a lack of evidence which can be applied to inform important transport investments. And the HVT program is intended to close this gap by providing a new system of knowledge about sustainable transport development in low-income countries. The focus is actually on low to medium income countries, and the geographical focus is on sub-Saharan Africa and Asia. There are some research areas which are prioritized under the HVT program, and these are climate mitigation and adaptation, inclusion, gender, road safety, policy and regulation, technology and innovation, fragile and conflict-affected states, research uptake, and capacity building. So this HVT program timeline spans over 8 years. It started in 2017, where there was the process of collecting data to find out where the gaps in knowledge were. And then after identifying this, the knowledge gaps, there were specific research areas, including the themes which were shown in the previous slide. So this current program is ending in January 2023, but we have also received an extension which is up to the year 2025, and the projects are to be confirmed in consultation with UK aid. The question we need to ask ourselves is why update the Road Note 31? But this is going to be presented later on by the consultant. We are also grateful to Mozambique for allowing us to participate in the data collection and to host the workshop. The ANE specifically provided some personnel who were actually involved in the field investigations, and in addition to that, engineer Irene is also a member of the project advisory steering committee of the for the development of the updated Road Note 31. Also, in Vietnam, we had the road authority participating in the field data collection, and Prof. Dang Tran Thi Kim is also a member of the project advisory group. What we expect the impact of the updated Road Note 31 is to address the impacts of climate change and mitigation against adverse social impacts which can result in community severance, and to use available technologies that can automate certain pavement design processes. This is just to show you the links that you can follow to get further information on this HVT program. Muito obrigado.
Muito obrigado, HVT. Agora vou convidar o senhor diretor-geral adjunto da Administração Nacional de Estradas para fazer a sua intervenção. Obrigado.
Bom dia, colegas. Permitam-me, em nome da ANE, como um dos intervenientes nesse estudo, saudar a presença dos representantes das firmas de consultoria que têm estado a trabalhar conosco, da própria associação, da Federação dos Empreiteiros que são atores importantes que têm estado a trabalhar conosco, da academia, que julgo que está aqui presente, também fizemos questão de convidar, porque achamos que estes instrumentos não devem só serem do domínio do setor de estrada, tanto quanto a Administração Nacional de Estradas, e também dos outros atores que aqui estão presentes, como a Ordem dos Engenheiros, que também formulamos um convite, julgamos que também estão aqui presentes, porque achamos que este é o fórum apropriado para juntos podermos partilhar aquilo que foi desenvolvido, e, sendo um documento vivo, julgamos que terá que ser sempre atualizado. Aos colegas diretores executivos dos serviços centrais, aos colegas delegados e demais colegas do setor de estrada, especialmente da ANE e do Fundo de Estrada, que estão aqui presentes, queremos, por via desta, saudar a presença aqui e o tempo que disponibilizaram para poderem estar cá conosco e partilharmos aquilo que foi o estudo realizado pelo consultor, no sentido de podermos atualizar o Road Note 31. E julgamos que as condições estão criadas para juntos podermos trabalhar nesses 2 dias. Queremos aqui também fazer referência que o Road Note 31 é um documento que vem sendo usado já há bastante tempo, mas que, pelas dinâmicas do dia a dia, há sempre uma necessidade de fazermos a atualização deste instrumento. Como sendo documento dinâmico, julgamos que há vários elementos, há vários fatores que já não se enquadram naquilo que é o instrumento que estava sendo usado. Fazemos aqui referência aos eventos cíclicos climáticos que têm estado a acontecer. Então, há alguns fatores que precisam de ser acomodados dentro deste instrumento que nós hoje vamos partilhar a sua atualização. Queremos também aqui saudar o financiador, que é o governo britânico, por ter escolhido Moçambique como sendo membro da Commonwealth, que é para poder beneficiar e fazer parte desta referência de estudo através dos corredores que foram identificados e fizeram parte do objeto deste estudo. Queremos aqui também saudar aos consultores que, mesmo depois da pandemia, tiveram a oportunidade de cá estar, tiveram a oportunidade de ir ao campo, fazer as análises, colher as amostras e, com base nos resultados que vieram destas análises, puderam preparar este manual que hoje vamos aqui apreciar. Não vou me alongar, porque isto é uma discussão técnica, é uma reunião técnica. Nós estamos aqui para ouvir e, estando aqui para ouvir, julgamos que temos de dar espaço aos que foram preparando este manual, que é para nos dizer mais ou menos quais são aquilo que são as constatações e quais são os caminhos que nós poderemos seguir face a esta nova abordagem, face aos eventos cíclicos que têm estado a acontecer. Falo aqui de eventos cíclicos.
Exciting times being the past presidency allowed his livestock to roam the front lawn. But what was once a simple
Tem estado a circular nas nossas estradas. Falávamos de antes de 56 toneladas na região da África Austral. Hoje estamos a falar de alguns elementos que transportam cerca de 72 toneladas e circulam nas nossas estradas. Naturalmente, observando aquilo que é a carga por eixo padrão, que é definido tecnicamente. Por isso, colegas, caros participantes, meus colegas de profissão, queremos com isso saudar esta iniciativa e fazer votos de que os 2 dias de interação com a equipe de consultoria que esteve envolvida na preparação, na revisão deste instrumento, deste documento, possam trazer aquilo que foram as constatações, mas também nós, como atores, como fazedores do dia a dia, naquilo que são as nossas experiências, também possamos contribuir para a harmonização deste documento. Dito isso, colegas, declaramos, em nome da Administração Nacional de Estrada, aberta esta sessão, este workshop, que vai ter a duração de 2 dias, e julgamos que também estão criadas condições do ponto de vista de espaço para podermos trabalhar durante os 2 dias. Aos organizadores, agradecemos por esta disponibilidade, por terem criado as condições para que esta reunião pudesse acontecer. E muito obrigado pela atenção que me dispensaram.
Sim, muito obrigado, senhor diretor-geral adjunto. Agora vamos nos apresentar. Vou começar de mim próprio. Meu nome é Calado Juana. Sou diretor dos Serviços Centrais de Planificação na Administração Nacional de Estradas.
Senão fica essa situação de dizer, esteve lá o diretor-geral adjunto, mas quem é? Nominalmente. Meu nome é Miguel Coanai, diretor-geral adjunto da ANA. Obrigado.
Thank you. My name is Francis Tangare, Project Manager with DT Global, specifically managing the delivery of the Road Note 31 5th edition. Thank you.
Obrigado, bom dia. Meu nome é Jaime Cruz, sou vice-presidente da Federação Moçambicana de Empreiteiros. Obrigado.
Muito bom dia a todos. Meu nome é Nelson Alberto Zanzana, sou diretor dos Serviços Centrais de Manutenção e Segurança Rodoviária na Administração Nacional de Estradas. Obrigado.
Bom dia, meu nome é Nasser Amir, sou auditor interno do Fundo de Estradas.
Bom dia a todos, meu nome é Gonçalo Jarroz Yanai, chefe de departamento técnico na delegação provincial da Animanica.
Bom dia a todos. Meu nome é Gonçalo Gilang, de Monxará. Sou técnico da Administração Nacional de Estradas na planificação.
Bom dia, meu nome é Raquel Langa, sou técnica nos Serviços Centrais de Projetos e Obras.
Bom dia, meu nome é Chaka Mofuyan, sou chefe da repartição de monitoria de emergências da Administração Nacional de Estradas.
Bom dia, meu nome é Elias Chamba, sou técnico da direção de Serviços Centrais de Geotecnia, Vias de Comunicação, Laboratório de Engenharia de Moçambique.
Yes, good morning to you all. My name is Andrew Otto. I am the team leader for the consultant TRL Limited in updating this road note. Thank you.
Bom dia, my name is Nigel Hewitt. I'm a principal highway engineer. I've been at TRL for 34 years. Thank you.
Hello, good morning everyone. My name is Manai Yonetu and I'm a drainage expert and author of the drainage chapter for the revised RN31 document.
Bom dia a todos, meu nome é Cremildo Mucavel, sou diretor de Serviços Centrais de Projetos e Obras na ANE. Obrigado.
Muito bom dia. Meu nome é Bruno Santos, técnico da empresa JJR Moçambique. Obrigado.
Bom dia, meu nome é Belzénia Matsimbe, sou docente e pesquisadora na área de vias de comunicação e mudanças climáticas. Estou em representação do Instituto Superior de Transportes e Comunicações, ISUTC.
Bom dia, Sérgio Sebastião, engenheiro civil, represento o Conselho Municipal de Maputo, Direção Municipal de Infraestruturas Urbanas, Departamento de Estradas.
Bom dia, meu nome é Cândido Edge, sou o chefe do Departamento de Estudos e Projetos na Revim.
Muito bom dia, Virgílio Citola, técnico da Administração Nacional de Estradas.
Bom dia, Armando Marins, técnico da ANE.
Bom dia, meu nome é Rubina Normalmed, eu sou a delegada provincial da ANE em Maputo.
Bom dia a todos, eu sou Washington Pazuripo, diretor da Escola do Sul Moçambique.
Bom dia, eu sou Dad Mendes Novelo, delegado provincial da ANE Inhambane.
Bom dia, meu nome é Adelino Serraj, trabalho para o Departamento de Planificação na ANE.
Bom dia, meu nome é Leonel Mohamed, técnico de Direção de Planificação ANE.
Bom dia, meu nome é Julião Tinguiça, chefe de Departamento de Planificação
da delegação da ANI, NS.
Bom dia, meu nome é Fernando Silva, Project Manager, Motengil. Obrigado.
Obrigado. Não sei se temos alguns participantes que estão conosco remotamente para se apresentarem também. Alguém está a participar no encontro remotamente?
Sim, sim. Bom dia.
Hi, this is Eric Singh from Fiji. Good morning, this is Eric from Fiji.
Thank you.
I work for Fiji Roads Authority, the road agency in Fiji.
Ok, thank you.
Sim, bom dia. Sim. Bom dia, Carlos Kumani, Laboratório de Engenharia de Moçambique.
Obrigado. Mais? Parece que não há mais ninguém. Diretor, vamos fazer o break agora. Desculpe-me. Colegas, de acordo com o programa, devemos fazer um pequeno intervalo de 30 minutos, das 9h30 até as 10. Mas penso que temos condições.
Okay, thank you very much. Once again, my name is Andrew Otto. I'm the team leader for TRL for updating the Road Note 31 that we are here to discuss today. I would like to, first of all, extend my thanks again to ANE and various Mozambique institutions like LEM, and various Mozambique consultants and contractors who helped us through this process. Mozambique has always been very helpful and cooperative
in bringing change and development in the road sector, in pavement design, because of its unique conditions, especially the climate change effects that have occurred in recent or the past 3 or 4 decades. This has offered a major learning experience for us who are in development of standards to learn from this and move forward to help not only Mozambique but also the rest of the continent, the rest of the low-income countries and middle-income countries. So I'm going to give a brief overview of the Road Note 31 that we have now updated. And my presentation, there is going to be the introduction and then the new Road Note 31 content, and I'll give a conclusion on this. As you can see here to the right of the screen, this is a cover page of the 4th edition of Road Note 31. It has been around for several years, since 1993, and it has stood the test of time and been a major basis for the development of other country manuals and guidelines in the tropical and subtropical regions. Now, the 4th edition of 1993, the title was Overseas Road Note 31, a guide to the structural design of bitumen surface roads in tropical and subtropical countries. Now, during the revision, the title was changed back to something similar to what we had for the 3rd edition and the 2nd edition. So it simply now is a Road Note 31. The word overseas has been removed. So it's Road Note 31, a guide to the structural design of surfaced roads in tropical and subtropical regions. The word bitumen surface has been replaced because it now contains the design of rigid pavements as well. And the word countries has been replaced with regions because in each country you can have several climatic regions, and some of which may not be tropical or subtropical. Now, what are the major additions to Road Note 31? The major additions include the design of rigid pavements, pavement rehabilitation methods, and climate resilience of surfacings, as well as pavement drainage, the climate resilience of pavement drainage. There have also been enhancements of other chapters, such as the chapter on traffic assessment, subgrade assessment, and the chapters to do with materials, because since 1993, a lot has been learned about various materials in road construction. To make the use easier, we also have a spreadsheet to help with some of the more complex designs, such as the rigid pavement method. The spreadsheet helps to make it much easier. Now, we will have a new desktop published layout of the Road Note 31. The copy you have on your table is not the final printed copy. The final printed copy is currently in the print being produced, and it will be all in color, and some boxes will be sent over to Mozambique. And we shall also have soft copies, digital copy, which will be uploaded on our website and various other websites, which you will be able to download. We actually advise that it's the website version that you should always be referring to, because through the process there will be minor additions or changes, so you'd have access to the most up-to-date information on that. Now, we also have included major principles, or principles that weren't well accepted in 1993, but over the years they have now been well accepted. So we've incorporated these principles in updating the Road Note 31. One of them is deterioration of roads designed for high traffic levels is primarily caused by bitumen aging, and this results in mostly cracks that start from the top of the surface and work their way down to the lower layers of the pavement. Theoretically, when you do analysis mechanistically, most of the models will say the crack starts from the bottom and migrates upwards, but field observations will show you that most cracks are actually coming from the top going down. There is also the fact that we now take for granted that deterioration is initially restricted to the surfacing layer. And at that time, if you address what is going on your surfacing, you will solve a lot of the challenges that you have with your roads. Now, another key principle is the fact that if you design a pavement to carry up to about 80 million equivalent standard axles, or 80 MESA, above that, the design in thickness of the pavement will not have a benefit in protecting your subgrade. And that is because with this level of pavement thickness, the stresses and strains in the subgrade are already so low that adding more material does not give you any significant benefit. The last major principle is the need to have strong foundations. And this goes hand in hand with climate resilience. That if you have a strong road foundation, you will save on the upper pavement layers, and the upper pavement layers are more expensive. So it's good to save on them. And the strong foundations will also not deteriorate as much when affected by climate change factors. I've included here a photo of some cores, asphalt cores, which have been taken several years ago, I think in Kenya, clearly showing cracks on the asphalt core coming from the top of the asphalt and working its way down, as opposed to coming from down and going up. Now, the Road Note 31 remains the Road Note 31 remains a guide. It is not a manual, and therefore it is not designed to replace the Mozambique Pavement Design Manual, which is now available. It is designed to be used with these manuals and with other guides. So it's supposed to complement or supplement where you may find a gap within your manual or in other guides. But it can also be used independently. If you need to use it independent of other manuals and guides, you can do so. And in revising the Road Note 31, we have emphasized, or we've put it at a level such that it incorporates a lot of flexibility in many of the processes that you undertake to come up with a design. Now, you will ask the question that why should you use this guide? And the answers are that if you're in a tropical and subtropical climate, it could help you produce better designs suitable for your climate. You do not want to take a design manual or guide made in a temperate or meant for temperate regions to use in your area, which is tropical or subtropical. Now, we have revised the structure catalogs in the Road Note 31, and we have checked it against mechanistic empirical approaches to make sure that it's suitable. We have also made several comparisons with other established manuals and guides to make it suitable and not be an outlier. We have also further checked the structures using the structural number method. So the content, we're now going to the content of, a brief highlight of the content of what's in the Road Note 31. And starting off with the chapter on traffic assessment, we have incorporated changes to the values of the damage exponent, which you use for establishing the equivalent axle load factors. Now we have several values depending on the pavement structures that you will be using. We have also dealt with the issue of axle configuration. As you know, sometimes dual axle has a different effect on the pavement structure than a single axle. And this means that its equivalence factor will be different. We cannot always keep using the standard axle of 80 kilonewtons because that would not be representative. And this goes along with the rise now in the use of super single tires. In 1993, it was not common to see a vehicle, a truck, using super single tires or the wide base tires. And these have different effects on the pavement structures. So these have been incorporated. There also is the fact that the rigid pavement design method we have chosen relies very strongly on identifying your axle configurations correctly. So this has made a revision in the traffic assessment. Further to that, just to illustrate the point I was making, these are some of the values of the damage exponent, which on the table to the left has the values of the damage exponent, with exponents which we have included. And the table to the right has the values of the standard axle loads that are applied to various axle load configurations. You'll note that the 80 kilonewton applies to single axle with dual tires. And if you have tandem axles with dual tires, it goes to 135 and so on. In subgrade assessment, the previous, the 1993 version of Road Note 31 allowed or permitted for assessment of your subgrade at the optimum moisture condition. But we know that in this current era, with all the climate change effects, it's very rare that in the 20 years or so that you design your pavement, the subgrade will always be at optimum moisture content. It's very rare. At least once or several times, the subgrade is going to be soaked and it will be, in fact, saturated at times. And those are the critical times when the road pavement fails. So we have removed the assessment of subgrades at optimum moisture content, and it is now assessed at a moisture which is determined when there is no further swell in the laboratory when you're testing. I've talked about 10 days soaking here because in Australia, I think about 5 to 10 years ago, when they experienced severe floods, some of their road pavements remained soaked for periods of longer than 10 days, and they therefore revised their design methods to have condition. They assessed the subgrade after 10 days of soaking in some of the states of Australia. We also thought that in the 1993 version, the subgrade was not very well defined. So as you can see here in this diagram, if you have a road alignment running in various terrain, some of your subgrades are going to be just on the surface of the road, as in scenario A. In scenario B, you're actually going to have an embankment, which means that it's a very different situation. And in scenario C, you're basically in a cut because you will not be able to access your subgrade sometimes when you're doing the investigation. And these are represented by these diagrams of where the native subgrade actually lies in relation to your pavement layers. And these scenarios are discussed in the road note. Now, unbound pavement materials, we have largely retained the specifications which are in the 1993 version, but we have included the use of recycled pavement materials, which can be used in other pavement layers or in the pavement foundation. We have also included the use of large aggregate bases, which are just beginning to grow in some parts of the world. They are not the same as macadams or Telfords because they are being specified differently. So these have been included, and they are very useful in areas where rock is abundant. On the chapter on hydraulically bound materials or cemented materials, we have introduced some new products which can now be supplied by cement manufacturing industries. These include hydraulic rod binders. They're growing now in popularity. They are basically low shrinkage products that have various constituents but enable you to achieve similar strength as the high shrinkage cements. So it helps in minimizing the shrinkage cracking that occurs. We've also taken on board the fact that some countries, they don't like to use cemented materials because of the need to keep the road closed for a few days after they're constructed. And there are now criteria which, when used, can actually allow you to open the road immediately to traffic after construction. In asphalt materials, asphaltic concrete or other asphalt materials, we've introduced other materials which are currently not contained in the 1993 version. Things like stone mastic asphalt, which are essential for areas where traffic is expected to have a very high loading, or the design yields very high MESA for these roads. As well, we have also included some aspects that enable the use of low air void materials. Now, there is a challenge which is being faced currently by many countries in the tropics, and that is rutting. Several roads are now rutting prematurely, just a few months or years after construction, you have severe rutting, as in this case shown here. And this obviously is a loss of resources, a loss of funds that are used to construct these roads, a loss of performance expected by the road users. So we have included several methods of producing rut-resistant mixes, such as the refusal density design method, quite cheap but effective, wheel tracking test criteria, alternatives like the use of the Bailey method for selecting your aggregates to avoid rutting. Some of these are actually included in the Mozambique pavement design manual already, so that is safe. On the opposite side to rutting, there are also several roads now in various countries where they get premature cracking. Just maybe 2-3 years after it's constructed, you will get cracks already forming. So we have highlighted in the road note methods of making your asphalt more durable and less susceptible to cracking. Now, in so doing, we also realize that TRL has already produced another road note 42, which deals with asphalt durability. So we have referenced this in, and you can actually, when you use the link, you will get to it and see some of the steps to be taken to improve asphalt durability. Climate resilience is a major topic everywhere these days, and it is also an effect which most countries have now experienced practically. So we have gone to great lengths, especially on the drainage of pavements, not drainage structures, but drainage of pavements. We've gone to great lengths to see approaches that can be used to at least address this issue of climate resilience. At the same time, we also are aware that climate change affects also the road surfacings, because that is the most exposed in terms of temperature. And we have put in the road note various methods of combating or strengthening your pavement to counteract or at least delay the effects that come as a result of the defects that come as a result of climate change effects. Okay. Yeah, so here's just an example of some of the common things that affect embankments a lot. I believe in Mozambique you must have encountered this at least in one of the cyclones that hit, and there are protections that are necessary to be incorporated in vulnerable areas. It may be expensive to incorporate it in all areas, but vulnerable areas should be identified and protected in this way. Or another way is protecting against capillary rise when it's not washed out. My colleague, whose presentation comes later on, will go deeper into these aspects of climate resilience. We also recognize that in the 1993 version of Road Note 31, certain terminology was not very clear, and it was quite difficult to distinguish which pavement layer was being talked about in certain cases. So we have included ways of defining various aspects of pavement layers. The team behind, can we get the projection back? Okay, good. Yeah, so we've defined now what we mean by various terminologies in the road note, and it's clearly represented in a diagrammatic way so that it's easy to understand what is being referred to. As I mentioned, there's a design of concrete pavements, also sometimes referred to as rigid pavements. And this will be our focus for tomorrow, rigid pavements. Today we are dealing with flexible pavements, basically. In rehabilitation, the rehabilitation chapter in Road Note 31 is actually very, very similar to what you have in the rehabilitation design manual of Mozambique. Very, very similar. Very largely actually the same, I would say, except this is a shorter version and may have one or two things to do maybe with inlays that may be missing in the Mozambique manual. So it's all stems from Road Note 18 and the diagnosis of defects before you carry out the rehabilitation, the approaches of dealing with each of these defects or a combination of them, the discussions on structural overlays versus overlays for function or for user comfort. The rehabilitation of concrete pavements is touched on but not in depth because of various specific things. So it's given mostly as a guidance, but my colleague may discuss that tomorrow. So we have retained the three pavement rehabilitation methods that are also contained in the Mozambique rehabilitation design manual. And the first is the structural number and the deflection approach. Then there is the deflection and the rod depth approach, and the analytical or mechanistic approach, which is very similar to mechanistic pavement design. These are some of the illustrations of the method which we recommend most. It may not be, of course, the method that applies in all situations, but it's an illustration of the structural number and the deflection approach, which is also included in the Mozambique rehabilitation manual. So in conclusion, there are some differences that exist between the Road Note 31 and the Mozambique pavement design manual. But as I said before, these differences are largely complementary in that what you may want more information on in your design manual, you may be able to find that more information in the Road Note 31. And where the Road Note 31 may not be so specific, your manual is still specific in that term or on that aspect. We also have the rigid pavements, which I've talked about, which Mozambique currently does not have its own rigid pavement design manual. You could be using this prior to developing your own manual. Traffic assessments, I admit there's a quite significant difference between the Mozambique manual and Road Note 31 now. The issue of subgrades, we are no longer doing the optimum. We're going for 4 days soft or until no further swell, but your manual still permits for assessments in some cases at optimum. We've also introduced one catalog which has a thinner asphalt layer than some of the structures you have in your current manual, but it applies in certain conditions which we shall look at later. We have an updated low volume sealed roads catalog contained in the RN31, based actually on the back analysis study which Mozambique participated also very strongly on. So it's a chance for you to benefit from that hard work that you put in. Climate resilience as well, we talked briefly about, then stabilized materials, which are also contained. Thank you very much. As you say, muito obrigado. Mr. Chair, I don't know if it is the break time or if somebody has a key question that we can take before the break, then we continue after.
Obrigado, Andrew, pela apresentação. Participantes, penso que tivemos a primeira parte do nosso seminário. Foi aqui apresentado em linhas gerais o que é o manual, qual é o conteúdo do manual, e esperamos que nesta primeira parte, se houver alguma questão, consideração, porque julgamos que esse manual é para nós como atores do setor de estradas. Chamo atores do setor de estrada da academia, nós fazedores, consultores, empreiteiros. Somos atores na provisão de infraestruturas rodoviárias. Os que estão a acompanhar via virtual também, se houver alguma questão, algum esclarecimento ou alguma contribuição, nesta primeira abordagem também íamos agradecer. Dito isso, o espaço é aberto a nós para podermos tecer algumas considerações, contribuições, depois desta primeira abordagem, que é naturalmente, em linhas gerais, apresentar o que é o conteúdo do Road Note. Obrigado.
Obrigado, senhor diretor-geral adjunto. Bom, penso que o primeiro apresentador fez mais ou menos aquilo que é o resumo dos principais aspectos que nós podemos encontrar neste documento revisto. Sei que teremos informações mais detalhadas com as intervenções da equipa que vai fazer as apresentações logo a seguir. Mas queria pedir para que os próximos apresentadores trouxessem um pouco mais de 3 aspectos que eu tomei nota. Esta questão de hydraulic binders para reduzir o shrinkage, como é que chama em português o shrinkage? É retração, né? Engenheiro Celso, shrinkage é retração, né? Ok, tá bom. Para a redução da retração. É muito importante isto porque nós temos maior parte do período em que as obras acontecem, temos calor intenso. E esta questão da retração é muito importante. É muito importante a gente perceber como é que isto se desenvolve. Temos também esta questão do top-down cracking. E o apresentador falou aqui que esta questão de top-down cracking é mais por causa do envelhecimento da camada superficial. Agora, o que eu queria que fosse um pouco mais aprofundado em relação a esta questão é: o envelhecimento é por causa das mudanças climáticas, ou o envelhecimento do binder é por causa do tipo dos binders que estão a ser utilizados agora no mercado? Porque pode ser que estes binders não estejam adaptados às novas condições climáticas. Queria ouvir um pouco mais em relação a este assunto. Porque, de facto, o que se espera num pavimento é que a camada superficial seja mais flexível até do que as outras camadas, porque tem um bituminoso que é muito mais flexível. E se isso não acontece, de facto, vamos ter esta situação do top-down cracking. A outra questão também que é muito preocupante nos dias de hoje é esta questão do super single. Estamos a ter muitos caminhões super single. Gostaria de ouvir um pouco mais detalhado de como é que esta situação é abordada nesta versão revista da nota rodoviária 31. Obrigado.
Bom, Engenheiro Calado fez aqui algumas considerações, questionamentos que podem ser objeto de contribuições. Estou a ver com o engenheiro Celso, a academia está aqui presente, quero também tecer algumas considerações. Faz favor.
Bom dia, Celso Nichols, Universidade Eduardo Mondlane. Aqui há 3 aspectos que eu gostaria de levantar. O primeiro é em relação às referidas 96 horas relacionadas com o ensaio de imersão. Nós fazemos normalmente ensaio de resistência de 96 horas e não 4 dias, mas o manual prevê até 10 dias submerso e sem ou com consideração de expansividade, porque ele diz no further swell, ou sem mais expansividade. Gostaria de ter esclarecimentos sobre o que está realmente a ser considerado no manual. Devemos considerar a avaliação em 4 dias ou a avaliação submerso até 10? Porque percebia que até 10 é causado, ou a principal razão é por causa da Austrália ter experimentado cheias e as camadas de fundação ficaram saturadas até 10 dias ou um pouco mais. O segundo aspecto que gostaria de ter algum mais esclarecimento é como é que se corta aquilo que é capilaridade, a subida das águas, porque o Drainage Manual sul-africano diz que nós normalmente temos de ter ao topo da estrutura de pavimento meio metro acima da altura máxima daquilo que é água encostada à plataforma da estrada. E por causa disso cometemos algumas asneiras no passado. Fizemos Xissá no Chibuto com uma altura de quase 2 metros, apareceu uma cheia e levou para da estrada. Eventualmente, considero muito bom a proposta de dimensionamento para overtopping. Já prever que a estrada pode ser galgada pela água e tomar medidas. Então, eu acho que são esses 3 aspectos que eu gostaria de ter mais esclarecidos. Obrigado.
Obrigado, engenheiro Celso. Não sei se temos mais alguma intervenção. O meu sentimento é que ainda temos algumas apresentações mais detalhadas de várias áreas e possivelmente algumas questões de contribuições que estamos a levantar agora poderão ser esclarecidas assim que as apresentações forem efetuadas. Por isso, Andrew vai tomando nota. Acredito que no final das apresentações poderemos ter algum esclarecimento. Caso não, se achar que há alguma questão que precisa de dar algum subsídio, algum esclarecimento, agora também pode dar. Já agora, em nome da ANI, do setor de estradas, uma das recomendações que é pedir, não à equipe de consultoria, mas acredito eu que ao financiador também faz parte e penso que a mensagem poderá chegar através da equipe de consultoria. Seria no final, na versão final do Road Note, termos alguns manuais traduzidos na língua portuguesa, que é para poderem facilitar aquilo que a academia a nível nacional poder também partilhar esses conhecimentos. Este era um pedido que íamos fazer. Se estiver já cautelado, é bem-vindo, mas se não estiver, penso que podemos trabalhar com o financiador, que é para poder suportar estes custos associados com a tradução do RN31. Obrigado.
Yeah, if I can respond to two of the issues quickly, because they are short to respond to. The first one I will respond to is the issue of top-down cracking. So the top-down cracking is the top-down cracking is coming as a result of a number of factors. It's not very new because top-down cracking has been reported as early as the 1980s, not only in tropical environments, but in countries such as Netherlands, France. In the tropical environment, I think it was first reported in Kenya in the 1980s. So by that time, the climate change effects were not as strong. They were not as strong as they are currently. So we cannot strictly say that it's a result of the climate change effects. At the same time, the current climate change effects also accelerate the occurrence of this top-down cracking, because it means that your bitumen or your binder oxidizes more rapidly, and it causes the bitumen now, after oxidizing, to become brittle and less resistant to the traffic stresses, so that a few of the traffic passes is enough to induce this top-down cracking. Otherwise, it is also, in some cases, as we've found, it is also related to the use of, when you're trying to combat the effects of rutting, you may specify a harder binder. But the harder bitumen has a very short, small window for heating and compacting to get the density. So if the temperature drops within a small window, you may not be able to compact it, and therefore contractors will tend to heat it to a higher temperature and thereby actually destroy the binder partially before they put it on the road, and then it will induce, the crack will induce very soon after construction. Within a few years it will induce. Of course, bottom-up cracking can occur as well, but in the tropical environment, the top-down will usually occur before the bottom-up sometimes even initiates. Before even the bottom-up has initiated, the top-down cracking may have already initiated, and causes your pavement to deteriorate, and therefore you have to intervene before the other ones have initiated. Largely, the tropical environment means that your bitumen will oxidize faster than in a temperate environment because you have more heat. In the tropics and you have intense rains, any crack induced quickly widens to a dangerous level. We shall, of course, explore this further during our 2 days discussion. The second thing which I want to respond to was a question raised by Engineer Celso. He asked whether the RN31 specifies 10 days soaking or it specifies 4 days soaking, and his worry was that the 10 days was based on the Australian case. In the RN31, we are specifying 4 days soaking or until no further swell, which means if by day 4 your material is still swelling in the mold, you have to continue soaking it until it stops. But if by day 4 the swelling has stopped, then you take your strength there at that point. So those are the 2 quick ones I would like to respond to. The issue of the ingress raised by Engineer Celso, my colleague is going to present, I think after lunch, he is going to address it. Yeah. So the other ones to do with the hydraulic road binders and super singles, we will address in detail later. Yeah. Thank you.
Ok, obrigado, colegas. Vamos fazer um intervalo agora de 20 minutos e voltamos. Do you want to say something? Ok, antes do intervalo, o colega quer dizer alguma coisa.
Muito obrigado, Engineer Kwanai, for raising the question regarding the translation of this document. Unfortunately, there is no provision in the current budget for this project for the translation, but I will raise it with my principals and then advise you of the outcome in due course at the earliest opportunity. And also have we will have further discussions with the consultant as well to get an indication of how much that will cost. So overall, it will depend on the business case that we present, including the availability of the budget. Thank you.
Ok, obrigado. Então, como dizia, vamos fazer um intervalo de 20 minutos e voltamos para a sala às 10 horas e 53 minutos. Obrigado.
then I'll do the task, which is the question that we will try to address. And then we will look at how to do the uniform subgrade sections and design the foundations, then do the pavement layers. And then we compare with what the result would be if we use the Mozambique pavement design manual. Yeah, so let's get started here. I'm not sure if I'm using the correct version of the presentation, but let's carry on. So there are, of course, two main methods of pavement design. One is the empirical approach, which is based on what you see or what you've learned from practice, that on roads that have been built in certain climates, certain conditions, and then from those roads you learn what to do and try to apply it in a similar setting. Then there is the mechanistic empirical, where you create a theoretical model of how the pavement behaves, and then you calibrate this model against what is observed in reality, and you'll be able now to calibrate, rather you'll be able now to transfer this calibrated mechanistic empirical model to different situations. So I will be addressing the first one, which is the catalog method. It's supposed to be the simplest of all. And the next one, mechanistic empirical, Dr. John Rolt will address. Now, the principal method in Road Note 31 is the catalog method, which was very popular. But as I said before, we have checked these catalog structures using mechanistic empirical principles. There is, of course, experience taken from tropical and subtropical climates, so it's quite relevant. In that sense, it's not, you cannot regard it as purely empirical in that sense. So let me present a task, and then in this task, we shall try to address it using the Road Note 31. So let us imagine that we've got a 16-kilometer trunk road, or primary road, which is to be designed on a new alignment. So we are not talking rehabilitation here, this is a new design. And let's say that samples of the subgrade have been taken at the appropriate depths to match the vertical alignment profile. And let's say the samples were tested in a laboratory, and the 4-day soaked subgrade CBRs have been provided. Now, as a pavement engineer, let's say your task is to design and provide at least 2 pavement design options for this alignment for a design traffic of up to 51 MESA. And I've chosen the 51 deliberately. You may ask why not 50, why 51 or 51.5, but I'll explain later why that is the case. Now, to continue with describing the task, let's say that you have capping materials or materials for use as an improved subgrade, and one has got CBR 15 and the second one has got CBR 30. These are, let's say these are available in your area. And let us say that you also have access to cement as part of your project. You have access to cement, which you can use to modify materials. But as is the case usually with pavement designs, I'm assuming this is a practice in Mozambique. As a designer, sometimes you're told that this one has got to be asphalt concrete on the surfacing, or this one has got to be surface dressing, or other from planning department. I don't know if that's the case here. Yeah. But let's say that it's been decided that it's got to be asphalt concrete. Now, usually, of course, the laboratory would have gone out, taken samples, put this in the, tested this, and presented to you the CBR results at the specified density for subgrades, which is usually 90 to 93% of the maximum dry density compaction. And you'll get a series of results like this. And then you're tasked now with designing the pavement. Allow me to get some water, my throat is drying out. So the first step in doing the design is you have to determine the uniform sections and the design subgrade classes. At this point, I want to say that many of you are experienced in this. You know the steps, and you've probably done these designs. But what I'm demonstrating to you here is what we've proposed in the RN31. It's not in any way trying to educate you, because many of you are already educated in this, but we're showing you the option that's available. So the second step is to provide the foundation, which is the capping options, what you can do to first initially protect your subgrade before you put the pavement layers. In the morning, I showed you a diagram of the pavement layers, and what we actually mean by the pavement layers is subgrade upwards. And the capping and the native subgrade, we are calling that the foundation or the subgrade itself. Now, after you've provided for the pavement layers, the next step is to, of course, specify your materials so that it can be added into the contract, which goes out to the contractor to construct. So let's go through the steps which I've highlighted before, and that is identifying the uniform subgrade sections. Now, in order to identify the uniform subgrade sections, there are a number of methods which can be used. One of them is a simple experience or simple visual observation. You go out to the site, walk around and say, all of this soil looks similar from the start to the end. So I have one section. Or you can say, from this point to that point, that material, this soil looks different. So this is another section. That is a simple one. Then there is the statistical methods here, like the cumulative sums. And there are others which are a combination of geological tests together with engineering tests to identify uniform sections. And that is, you classify your materials according to soil descriptions, either as gravels, clays, or silts. This method is available in the RN31, where you can use first a geological classification, then you delineate your sections, and after that, you now have uniform sections. Now, I'm going to describe the method of the cumulative sums, and I'll demonstrate that next. So after doing the cumulative sums, which is the cumulative sum is the summation of the difference between each value, which means each CBR which you saw there, minus the average or the mean. And then you sum all of that and plot a graph, which is step 2. And based on that graph, you'll see where the changes are. And the locations of those changes represent the change from one section to another. And that helps you to pinpoint, but we shall see that. And then in step 4, you will have the reliability level which you're going for. In RN31, we recommend 95% for trunk roads or primary roads. Some agencies can recommend 90% for trunk roads and so on. After you've got your uniform sections, you now determine the design strength of each of these sections based on the reliability level you have selected. And that means you now know your subgrade strengths and you know your sections. So let me hope that this Excel sheet will open. Yes, it has. Now, I've taken the subgrade classes here, which are taken from the road note itself. So this will help us to decide which subgrade class we're in. So we will refer to that. And the data which we have been given, I've put it here. These are the subgrade CBRs that we've been provided. Now, how do we go about doing the cumulative sums? So in column I have the chain edges at which the samples have been taken. In column J, I have the test results, which are the CBRs of the subgrade. And now we start in column K with the first step in determining cumulative sums. And as you can see in this formula, I'm taking the measured value, which is 7 here, minus a value in cell J35. So if I scroll down to J35, I find that this is the mean or the average of all the values from chain edge 0 up to chain edge 16. So this is our alignment. We want to now find uniform sections. I appreciate, and if there are contractors in the audience, they are going to say, this is too short, you shouldn't even have more than one section. But this is just a demonstration. In another case, the 16 could be 60 kilometers or 80 or whatever. Now, this is done for all the values. You simply take the value minus the average or the value minus the mean. Now, after you've done that, you now start the process of generating the cumulative sums. And that means you start cumulatively summing this difference. So, of course, this is a sum of itself, so this remains the same. The next one is, the next cell is the previous one, this one here in L3 plus K4. Then the next one will be L4 plus K5. So you do all of those sums until you reach the end. Doesn't always end with 0. Sometimes ends with a different value. Now that you would have done your cumulative sums, the next step is to do a plot so that you can see visually where the sections are changing. So you have to see it visually. So you do a graph which shows the change on the x-axis and then the cumulative sums on the y-axis. And I've already done this graph. Done this graph, as you can see here. So that plot will generate a graph, not always of this shape. Sometimes it starts from up, goes down, and then does something. Sometimes it actually remains almost flat without doing anything. That's automatically telling you that there is nothing going on there. There are no changes. It's all one section. Now, here is where your engineering judgment comes in. The first time you'll be applying now something which is based on your own judgment and not based on strictly numbers. So you have to observe this curve and see where are the significant changes, because the statistic is helping you to pick out where a change in values starts rising and remains the same, and then another change in values remains the same. So in my case, I have decided that the change happens at this point. That is where the first significant change. There are, of course, these slight changes, but I'm not taking them as significant. So the first significant change happens here, and the graph takes off. And then I reach somewhere here, another significant change happens, and the graph dives down. So in my case, I would say there are 3 sections here, 3 uniform sections. Another person could ignore this change here, which is happening at 6.5, and say, that is all part of what is rising here. And they'll say, I have 2 uniform sections. So they would ignore the first one. Now, depending on how you select your sections, you will end up with different subgrade strengths that you have to design for. And that means that in this room, we could have as many as, say, 10 different designs based on people's different perceptions. Now, I've decided that the first section ends at chainage 6.5, and the next section ends at chainage 10, and then the last section at chainage 16. So for each of these, if you remember, we chose a 95% reliability level. We want to make sure that whatever design we're doing, we are guaranteed that the structure will perform 95% of the time, or 95% of the structure is safe when subjected to the traffic load that we are designing for. So we base our strength on, if you say 100 minus 95, we base our strength on the 5th percentile, which means the 5th lowest strength. So any strength, our design will be okay for any strength higher than what we will have chosen or calculated. So in this case, I would take the 5th percentile as computed using this formula, which is automatic in Excel, and it would comprise of the values ranging for, if you see the blue highlight here, it's ranging for my first section. And I would do the same for the next section and the same for the third section. Now, it's given me values of CBRs based on this reliability level. The first value is CBR of 6, the next one is 10.3, and the next one is 3, right? Now, you can compare straight away from this little table here where which subgrade class you fall in. So the first one of 6 falls between 5 and 7. So it is, sorry, let me zoom in so that it's more clear. 6 falls between 5 and 7, so it is subgrade class S3. The next one is 10.3, 10 falls between 8 and 14, so it is S4. The third one is a bit tricky because it's 3. Now, S1, the class says it's less than 3, but we have a value which is equal to 3. And this is also another critical point at which engineering judgment comes in. Some engineers are willing to take more of a risk, and they're going to say, okay, the 3 is going to be in class S2 because 3 to 4, that's okay. Other engineers will be more conservative and say, no, this is class S1, and they will go with a lower strength. But because I'm using a high reliability level, I've chosen to take more of a risk, and I've labeled mine as subgrade class S2. Now, at this point, we have already identified uniform sections, and we have identified the subgrade strengths and classes for these uniform sections. Now, let me carry on with the presentation. So this is the graph which we saw in the Excel. And based on, sorry, there's a typo here, it says S5, but it's actually S2. So based on the results, we have in this slide our uniform sections, we have our subgrade strengths at 95% reliability, and we have the subgrade classes. So we move on. Now, we now have to design the foundation. That means what we are going to put our pavement structure on, which can be several options, as we are going to see. Now, the purpose of designing the foundation is to ensure that the pavement layers, the sub-base, base, and surfacing, have got adequate support. Now, if you design a strong foundation, it will minimize the thickness of the upper pavement layers that you require. I think it even works for buildings, perhaps. If you have a strong foundation, you don't need to have a lot of reinforcement to carry the building, perhaps. Now, by having thinner layers, it means you are reducing on cost of materials required to build the pavement. And I remember in our case, it is stated that we have got capping options. We have 2 capping materials available. One had a strength of CBR 15, another one had a strength of CBR 30. Now, if you go to key 2 and key 3 in chapter 9 of the road note. Let me try and see if I can get it here. Okay, so we have got capping options depending on what you're aiming at. So let's say in our case we had an S3 foundation, an S3 subgrade on the first section, then we had an S4, then we had an S2. So I can decide that I want to design my pavement in such a way that everything is equivalent to subgrade class 4. And that means I have to upgrade what I have as S2 until it's equivalent to S4, and what I have as S3 up to S4 equivalent, and what I have as S4 remains as S4 because I'm upgrading to S4 equivalent. I can also decide that I want to upgrade my subgrades to be equivalent to S6. So what I have to, on S2, I say, let me make my S2 the same as an S6, let me have my S3 the same as an S6, let me have my S4 the same as an S6. So here, in this table, you have different options to help you achieve that. So I can see here that if I have a material classified as GC, and I want to get a class that is equivalent to F2, I have to add 250 millimeter of a material GC. If I have S2, and I want to get S6, I have to add 400 of that material. If I have S3 and I want to get equivalent to S4, I add 150 of this material. And if I have S4 and I want to make it as strong as an S6, I add 200 of this material. So this is one of the flexibilities that I was talking about in the morning, that you can apply different capping materials to get different subgrade equivalents that you're looking for. And the capping materials tend to be cheaper than pavement materials. So if you achieve a higher strength to start with, it means that you'll use less of the pavement materials. So let's go back to the example. We reached. So if we are trying to achieve the S4 that I talked about, we have to apply different thicknesses to the existing subgrade classes. So if we have an S3, we can add 150 millimeter of a granular capping, CBR 15, and it will allow us to achieve equivalent of S4. The S4 remains an S4 in itself, so you don't need to add something to it, you leave it as it is. And the last one, an S2, to get it into an S4, this was supposed to be 250. There's a typo here. You add 250 and it gets you to the equivalent S4. So at this point, you would have established one of the foundation options. Now, you can also do another foundation option, and you say, I want to make these things equivalent to F4, which is basically a subgrade class of S6, which means it has a strength of more than CBR30. So in order to do that, I've chosen that I'll use the stronger capping material because now I'm aiming at a higher class. Again, from the same table in RN31. And you see that I require now different thicknesses to get to that level of having a subgrade which is as strong as an S6. Remember, the subgrade I'm talking about here is a combination of the capping material and the native subgrade, what was there originally before we started anything. So I apply on what was there originally, these thicknesses of the materials, and it allows me to have a high strength of now the foundation, what we call the foundation, which is a combination of the capping as well as the native subgrade. So to have that strength. Now, having done that, we can now define our pavement layers. That is sub-base, base, and surfacing. And that would complete the structural design of the pavement. Now, in the first case where everything was equivalent to an S4, if you go to a chart labeled C2 in chapter 9 of the RN31, you will find options. So let me once again exit and go over there. And I will explain why I've chosen chart C2. You'll find in the RN31, the charts have limits. Some charts don't allow you to, they are limited to certain traffic levels, so you can't go beyond those traffic levels. So for example, C1 stops at 50. It doesn't go above 50. And that, if you remember in the beginning, I said the traffic was 51 MESA. Now, the 51 MESA here is again another point where engineering judgment can come in. As an engineer, you may ask yourself, how reliable was my traffic estimation? Was it overestimated or underestimated? And if you feel that it was overestimated, you can actually say, no, I'm going to use the structures between, in this case, in this case, you can say, I'm going to use the catalog for the traffic range 30 to 50. You say 51 is just slightly above, and I think my traffic was overestimated. And if something goes wrong, maintenance will pick it up. Somebody in demand may be very angry if they hear somebody in project saying, let's pass this on to maintenance. So you can make that judgment at that point. Now, but in our case, I've chosen to actually follow the rule and say 51 falls in the traffic range 50 to 80. And we have got a catalog here, which does that. And the first option I have is where I've made all my subgrades equivalent to S4. So I then pick out this line here. The mouse is not responding. So this line here, F2 or S4, and then this column here, 50 to 80. So I'm here. and I read out this structure. Now, below that, you'll find what these shadings mean. So the first one is asphalt concrete, which is AC or a hot rolled asphalt. Then the second layer is a dense bitumen macadam. The third layer is a granular base or a bitumen stabilized material. And then there's a hydraulically bound material, CB1. I set my question, so you remember I said available to you is cement, and they have decided that the surfacing should be asphalt concrete. So I set the question, hence I came to this chart. But if the question is not set to you, you can explore more and more options. If we make everything equivalent to S6, which is a stronger subgrade, you can see that we are saving on the base and the sub-base. The other one was, we had 175 and 250. Now, if we are having a stronger foundation, we will have 150 of base and 150 of sub-base, which are basically minimum constructible thicknesses. You could go lower, but for good construction, you must have some minimum, which you cannot go below. So you would have saved on that by making your foundation stronger if you have availability of various foundation materials. So it allows you to do that. So, so you'll have, of course, this design, which you have put on for the first foundation class, option 1. Option 2 is what I talked about, 150 and 150, which now allows you to progress. In the afternoon, when we do rationalization of designs, I will discuss how now you decide between the different options that you will generate at this stage. How do you decide that which option am I actually proposing for the construction of this road, for the provision of this road? Manai, are you tracking my time or not? How much have I used? Okay, so how many do I have? Maybe 10 or 15 minutes maybe. Okay. Okay, thank you. So allow me to show you an alternative which you can use, but using now structural number approach. So in chapter 9, we have chart E, which is based on structural number. So it just gives you a structural number. A structural number is basically coming out of the Asher Road test of the 1960s in USA. So they devised a system of defining the strength of a pavement by using one single number. And you say, this represents the strength of this pavement, that represents it. And the structural number is calculated by multiplying the material coefficient with the thickness of that layer in inches. Material coefficient represents the strength of that material, and there are tables available. There are also tables in the RN31 in chapter 11. There are tables showing the coefficients of various materials. You have these tables in the Mozambique Pavement Design Manual. You also have these tables in the Mozambique Rehabilitation Manual. So you don't have a shortage of that. Why am I going to demonstrate this structural number method? I'm doing so because not everyone has access to the same materials. In the previous example, I used asphalt concrete, a granular base, a cement stabilized sub-base. but not everyone has access to that. Somebody may decide that somebody may not have access to a granular base and says, instead of using the granular base, I am converting this granular base into a cement stabilized base. Can be sand stabilized base. Somebody can decide that I'm going to use an emulsion treated sand base instead of a granular base, because they don't have access to the granular base that we are specifying in the RN31. So with these material coefficients, it allows you the flexibility to define your pavement layers depending on the materials that you have. And you have to exercise some of the engineering judgment that we talked about. And allow me again to go back to the Excel and click on this structural number approach. Zoom in. Okay, so in this case, from table catalog E in chapter 9, at this traffic level, T10, and a subgrade class of say S6, which is foundation class 4, the required structural number is 4.05, which I chose here. And of course, at F2 or S4, it's 4.71 because it's a weaker subgrade. So let's look at the 4.05 case. Okay, so I'm targeting to get this structural number 4.05 or higher to be able to achieve what I need. And I have to combine the different layers in such a way that I can achieve what I'm looking for. So I could choose that I am going to have, instead of the standard asphalt or asphalt concrete, I'm going to have a binder course, an asphalt binder course, or an asphalt base, which is really stiff. So you see the coefficient here is 0.45, and it's supporting the asphalt wearing course with a coefficient of 0.35. Again, these coefficients are in chapter 11. You can find them there in a table. So I can say I have limited stone in my area, so let me just make this mix as stiff as possible, and it will help me to act as the base because I have limited stone. Then I'll have a cement-treated sand base, sub-base of a lower quality. In the previous case, we were dealing with CB1, and let's say in my area, I cannot achieve CB1, but I can achieve CB2, a lower quality strength of the sub-base. So with these coefficients, I now change the layers and see whether I am achieving the structural number that I'm looking for, 4.05. So if, for example, I say that if I try a 30 millimeter wearing course, you see that the value here has dropped to 3.9, and it's less than this, which I'm targeting, so that is not sufficient. So I can increase now this to 40. Again, at the end of this session, we'll circulate both the presentations and this Excel spreadsheet for you to keep. So at the same time, I can also say, okay, instead of having 110 here, the contractors will find this difficult to build. Let me have 125. And then I suddenly have again a very high value and I say this is not economical, so I have to think economically, and you can drop this down to 100 and it's again less, and I settled for 110, which is a bit awkward, but it's very close to 4.05, and I'm taking that risk with the 0.01. So as a designer, you will constantly be making personal choices and judgments which affect the final outcome of what. Okay, thank you. Yeah, so we did this structural number example. So you'd have 40 of AC, then you have 110 of a binder course, which is stiff, and then 300 of a weak quality or weaker quality cement stabilized sub-base. Now, how does this compare with the catalogs you have in the Mozambique manual? You will ask. Before I even say that, I must say that in the Mozambique manual, you also have several choices of different catalogs, and you also have structural numbers, which you can use. However, one particular catalog which I compared with was in your manual, in the Mozambique manual, it is called chart D1. In chart D1, you have, given the same foundation, you will have, in fact, not given the same foundation, because it requires different thicknesses of the foundation. So in chart D1, you have 90 millimeters of asphalt concrete, which is sitting on 220 millimeters of an asphaltic concrete road base, and it's sitting on 175 millimeters of a material of CBR30. And of course, that's applied through because we have the same foundation, which is equivalent to S4. Now, immediately, you will notice here that if we go to this option, in road node 31, we will have a thinner asphaltic layer. We have 40 and 60, but we have quite a thick sub-base, which is cement stabilized for that option. Now, so the comparison goes that in chart D1, you're using a thicker asphalt layers, but you're basically skipping stabilizing that sub-base, and you're going for a granular sub-base. So you have eliminated one material in this chart, which is cement. You've taken it out. Now, because of, you can also argue that that chart is very good where you have scarcity of crushed rock. Okay, thank you. I'm almost through. So you have a scarcity, if in areas where you have a scarcity of crushed rock or road-based materials, then that chart is quite good. Now, in the RN31 chart, where you have all of these various materials, it could be very useful in the case where you actually have high quality bitumen or high quality or modified bitumen or something that you can use to achieve your thin asphalt layer, and you also have cement. So this one allows you to have thinner asphalt, and in some cases asphalt can be very expensive, and it's usually actually the most expensive layer. So if you've got cement, which in many countries is locally produced, you can achieve a stabilization, build your strength from the lower layers, and use less of the asphalt to achieve the same strength. So in summary, this is actually an additional option for a designer who can say, okay, I've got this option, I've got that option. So it's providing you with an additional option. You can try as a homework, if you have the time, and try to redo the same design, but with traffic of 42, and you see what comes out. But if you've been limited now to only one capping material, then you can see what comes out. So in conclusion, the design process is simple. Using the catalog design is simple, it's basic. If you take the right steps, you don't have to sweat with a lot of numbers, because the comparison or the harmonization with mechanistic empirical has already been done for you by the team to make it suitable. The RN31 adds value to Mozambique and other country pavement design manuals because it's giving you additional options. Now, you also as a designer will have several options available to you, and it's always good to generate those options if they're not available and make a comparison and before selecting the appropriate one. Yeah, I think that is the end of my presentation on this particular aspect. I think I hand back to the chair to get the questions in.
Obrigado, Andrew, pela apresentação. Estando esta apresentação relacionada com a outra que segue, íamos pedir o líder, Otto, que é para também fazer a sua apresentação, e depois teríamos uma sessão de discussão e debate e apreciação das duas apresentações. Se assim concordarem, estou a ver aqui pelo conteúdo da primeira que o Andrew fez e da segunda, uma é catálogo, outra é mecanístico, e penso que estão direto ou indiretamente relacionadas. A não ser que Andrew tenha coberto as duas partes da apresentação, mas acredito que não. Temos mais uma apresentação. Não sei, caros participantes, se assim concordarem, podíamos já proceder desta forma. Aí facilitávamos já a discussão e o debate. So,
the next speaker is on Zoom. John, can you come in? Can the team behind allow John to share his screen?
Undo, sorry.
You're muted.
I'm muted. Sorry, is that, am I muted or not muted?
You're not muted, they can hear you.
I don't know whether they can hear me or not.
Just confirm.
Okay, thank you, everybody. The next presentation is about the theoretical approach to payment design. The usual program that is used to do theoretical analysis is the multi-layer linear elastic theory. A lot of people rely upon this, but there are some limitations which you need to know about. The assumptions of linear elastic theory are not all true, or only partially so. For example, all the layers comprise uniform linearly elastic materials. In other words, the stress equals the elastic modulus times the strain. Many materials are not, sorry, can't get rid of this, are not very linear. The value of E is not a constant. Oh, you just get rid of it. Okay, very helpful. Okay, thank you. Secondly, the layers are not homogeneous. The assumption is that there are no discontinuities, no cracks, no large voids. What's that? What was that?
I've just switched the presenter, you just carry on.
And thirdly, there is a significant lack of agreement between the calculated properties and the properties that are measured in real roads. So the MLET is not perfect, but it is used quite successfully. It's surprising, perhaps, that the method is used so frequently and with apparent success. So we have to ask, why is this so? First of all, the errors in the mechanistic method itself are usually systematic rather than random. This means that the relative difference in the results for different pavements are much more meaningful than the absolute values. In other words, if you can do the calculations for a pavement that you know works, then you can look at other pavements using the same methods and they should work too. So the relative differences are the importance. If a method can be calibrated by comparison with measured performance, very sensible conclusions may be obtained. So in other words, the method allows you to extend your design charts in a logical manner to structures that you perhaps haven't used before or whatever. But it does require the calibration to be correct. And this means that the performance of the pavements that we use to calibrate the method must be thoroughly understood. You'll see why I say that later. We need to know what the form of deterioration is and what the reasons for failure are so that we can design to prevent those failures occurring. Now, the other point is that most pavements that you design will not differ very much from those that should have been used to calibrate the MLET. In other words, if you're designing another pavement, it won't be very different for pavements that you've already designed, basically have used successfully. In other words, the pavements that Andrew's been talking about. So the new pavements you're now going to design for slightly different materials or different traffic levels will not differ by very much. Andrew's already mentioned the materials that you'll be using for unbound bases, asphalt surfaces and so on. So those will be the same materials and the thickness ranges typically, as you saw from Andrew's presentation, the thicknesses are not going to be very different between the different pavements you're designing. So because you're designing pavements very similar to ones that you know have worked, you can actually get some good results. Thus, provided the MLET has been calibrated for the specific type of structure that is being considered, there's a very good chance it will predict the relative performance of similar pavements with reasonable accuracy. This is the reason why many people still insist on using MLET despite the deficiencies. This is just a summary of what I've just said. The mechanistic method works because the errors in the method are often systematic, at least for similar structures. Therefore, a model will work better in predicting relative performance than it does in predicting absolute performance. The performance criteria need to be well calibrated against actual performance. And thirdly, the pavement being analysed must not differ too much in structure from pavements whose performance is known, i.e. the pavements used for calibration. So with these provisos, we can press on with the theory itself. Here's a worked example. This pavement has successfully carried 1.1 million equivalent standard axles of traffic over a 12 to 15 year period. It's made of a crushed stone road base, a granular subbase, a capping layer, and the subgrade CPR is in the range 5 to 7%. So this is the pavement that we're going to use to calibrate the MLET. Don't forget, the pavement has successfully carried 1.1 million equivalent standard axles. The data for this road provide the information for calibration. This is shown in the next slide. Step 1, the first step is to calculate the stresses and strains at critical points in the structure created by the equivalent standard axle as the usual loading configuration. In this example, the critical stress and strain is the maximum vertical stress or strain on the subgrade. Now, I must mention this is a very important point. You must know what the form of deterioration or form of failure is in the road that you're using. Critical stresses and strains elsewhere in the pavement can and do occur, causing different failure modes, but the basic principles of analysis are broadly similar. So as long as we know what the failure mode of our critical pavement is, we can use the MLET to design other pavements on the same basis. To use a multi-layer elastic program, the following data are required for each calculation and for each pavement layer. We need to know the elastic modulus of the material. We need to know its Poisson's ratio, basically two parameters that you need for any elastic analysis of anything. We need to know the load configuration. Normally we use a standard axle, which I'll describe in a moment. The layer thicknesses, it is necessary to test to identify the thickness of the layers in the pavement that will carry the traffic loading for the additional traffic levels that we want to design for. So we know our pavement has carried 1.1 million standard axles. How do we design a similar pavement that will carry higher values of traffic? The values for the selected pavement layer materials are shown in the next two slides. So this is the pavement we're using, the road base, similar road base to one that Andrew mentioned, subbase, capping, and subgrade. These values are obtained from the, let's go back. These values are obtained from laboratory studies of the materials, standard tests in the laboratory to obtain the elastic modulus and Poisson's ratio. As I said, the load conditions are usually used are a representation of the dual wheel at the ends of a standard axle. This comprises two circular loads of 20 kilonewtons applied with a pressure of sigma of 577 kilopascals. If you use that configuration, the radius of contact for each wheel R is about 105 millimeters. The distance between the wheels is also 105 millimeters. So this is your loading structure, 2 wheels of a standard axle with the dimensions just mentioned. Now, during the analysis of pavement performance, as I said, we have used a road that has carried 1.1 million standard axles. The loading for all trucks and heavy vehicles is converted to equivalent standard axles. There is controversy about this because it cannot be strictly correct for all wheel and axle configurations. And the reason I mentioned this particular issue is that a number of recently designed trucks have fairly different wheel and axle configurations to those that we've been used to for the last 20 or 30 years, specifically higher axle loads and higher tire pressures. Also, we know that many drivers overload their trucks, often to increase the tire pressures so they can carry more load. So the standard axle will underestimate the pavement damage. Some axle configurations, super singles, for example, are themselves inherently more damaging than the standard axle. Both these problems can be dealt with during pavement performance analysis by increasing the standard axle values for particular vehicles. So our axle load surveys or our surveys of the traffic, we need to take these things into account to estimate the typical ESA loading. So as I've said, we came with a figure of 1.1 in our example, but that is made up in a fairly complicated way these days. Now, there are several basic multi-layer elastic theory programs that you can use. Some are freely available. I think the one that I've used here is called KenPave. The programs all require the X, Y, and Z coordinates of the locations where the stresses and strains are to be calculated. The programs then provide a tabulation of the stresses and strains and the displacements in all 3 directions at all the locations that you've identified. Hence, a very large amount of data can be produced. In the example I'm quoting, we are looking at the maximum vertical stress and strain at the top surface of the subgrade because we have determined that it is the excess stress and strain at the top of the surface, top of the subgrade surface, that is actually causing the pavements to fail. So we've identified the mode of failure and we've identified the stresses and strains that we need to calculate. Off we go to our program, click the Go button. To achieve agreement between the number of standard axles that the road carried, i.e. 1.1, and the predictions based on the actual subgrade strain criteria, there are 2 ways that this can be done. Method 1, we can develop a new subgrade strain criteria. To do the critical strain, the critical strain that caused failure must be measured. The format of the subgrade strain criteria is this: number of standard axles equals this. Now, this has been the result of many studies by many research laboratories. It is a standard equation for the subgrade strain criteria. And in this particular case, I'm assuming that we have measured the subgrade strain on the road that's failed. And we've measured it and it becomes 855 microstrain. As you know, we've carried 1.1 million standard axles. So substituting in this equation, the value of the coefficient A, it becomes 5470. This is then the calibrated subgrade criteria, and we can use this in any other analysis of any other pavement. And as long as we reduce the strain below the critical values, then the road should perform perfectly well. But the problem with this method is it's really like developing your own criteria, subgrade strain criteria. And that is really a research project. And very few organizations will be doing this. This is the way, basically the way the design charts were set up by the research organization who actually did the design of the road. In other words, it's the way we would have developed the Road Note 31 designs at the beginning. So how would it normally be done? The more usual method is to select a subgrade strain criterion developed by a reliable research organization. The subgrade criteria usually conforms to the following equation, but the value of A depends on the properties of the subgrade and is usually related to the CBR or the classification of the subgrade material. Now, the question is, whose subgrade strain criteria do you use? If you look in the literature, you will find that there are probably at least a dozen different subgrade strain criteria. The main problem that has beset us for many years is that the one developed from the famous AASHTO road test in the 1960s, where, as you probably remember, the subgrades there used to freeze and become very stiff in the winter. And then in the spring, the freezing conditions thawed out and the subgrades became very, very weak. So it's actually quite difficult to define or to identify the subgrade strain criteria. And the equation developed at the AASHTO road test, which has been used for 20 or 30 years by different people, is actually very, very conservative. All the studies that we've done since show that that is not the best solution to use, and the subgrade criteria developed by others is much better. The two that we would recommend you looked at, one is the one developed by Lynn Irwin and Vincent Janoun team, who carried out between 1997 and 2002 in the US Army's Accelerated Testing Facility in New York State. A very comprehensive study and produced subgrade strain criteria. It is very similar to the one that was developed in Australia, which we quote in our research reports. So using one of those two, you can, let's get to the next slide, I'm sorry. The predicted traffic capacity of the candidate pavements are shown in the next slide. So this is based on the subgrade strain criteria that I've just mentioned. The original structure is shown on the left-hand side here. My pointers. This was the original structure. This is the traffic that it carried, 1.1 million standard axles. These are the structures that we would design using the subgrade strain criteria that I've also just mentioned. And we noticed that for T4, the subgrade strain criteria from the two studies I mentioned would indicate that this road should have carried 3.8 million standard axles. In fact, it only carried 1.1. So quite a big difference. And as you can see, this is what if we followed the current structure through to these other designs, we would only carry these numbers of standard axles. Whereas if you used these subgrade strain criteria that I've also mentioned, it should carry a lot more. Now, this is perhaps a little bit surprising, but because the difference is quite large, but this is actually not so surprising. The predicted capacities based on the uncalibrated theory are about 2 times the measured values on the original road. This is not unusual because the variability in performance of nominally identical pavements can be very wide. If, for example, you look at the AASHTO road test results from many years ago, you'll find that the variability between supposedly identical pavements is really quite large. And in the Astro road test design method, there is a safety factor, quite a large safety factor built in, which takes that into account. It will also be noted that the candidate pavements all satisfied the traffic capacity requirements based on calibrating in the way I mentioned, and are near to the upper level for the traffic classes that were the target. So we've actually managed to correct the designs for the traffic we require, but we've had to, as I say, identify the cause of failure and use that to do the calibration. Now, why is that a problem? There are also a variety of ways the road can fail based on different stresses and strains in the pavement structure. Therefore, it is very important to understand how your roads are failing and where the critical stresses and strains are in the various pavement structures. To calibrate any theory successfully and accurately, including the multi-layer elastic theory, the critical stresses and strains for every observed and verified mode of failure must be measured and the critical criteria developed, as I've shown in this example. The problem is that to measure the stresses and strains in pavements is really a research problem. You can measure, the one that's been measured most frequently, of course, is the stress and strain at the subgrade level, because essentially that you're building the road to protect the subgrade. So that is not so much, that's why I've used that as an example. But if you have other modes of failure, it is very difficult to know what those critical stresses and strains actually are by measuring them, because, as I say, that's really a research study. So I'm not suggesting that anyone who wants to use MLET actually does that, because that's really a very difficult thing to do. In this worked example, I have assumed that the pavement we are using for calibration failed because the structure was not sufficient to protect the subgrade any longer. Hence, it was necessary to design the new pavements to reduce the vertical stress and strain on the subgrade to lower values by means of the calibration. I've said this is probably the most reasonable assumption to make with only limited data and no detailed performance study available. Measuring the relevant strains at subgrade level to facilitate calibration is possible, but very few other stresses or strains have been measured to the same extent in research studies. Hence, any other calibration for another mode of failure is actually almost impossible. But to protect your subgrade and get your overall thickness correct, this is fairly okay, as I've described. So just to summarize, it is possible to, because the strains on the subgrade had been measured, and because it was fairly certain that the mode of failure of this particular pavement was known and is correct. But the message I'm really putting out is any other mode of failure is really quite difficult to deal with using the multi-layer elastic theory, because we don't know enough about what the critical strains elsewhere might be for other forms of failure. But for the main cause of failure, i.e. the subgrade protection, it is perfectly okay, as in the example. Oh, please introduce yourself at the end. Oh, sorry. I'm sorry, I don't think the sound was working at the beginning. For those of you that do not know who I am, I have been to Mozambique many times, and I was the main author of the 4th edition of Road Note 31, and I am sort of overseeing a lot of the subjects for the new version. Yes, I'm actually defined as the lead author because I am actually overseeing what everybody else is doing, but it's only I obviously can't write all the chapters myself, and we've got some very good people doing that. Okay. Okay, I believe I've finished my presentation, and I think I'm on time. Apologies if I'm not. I can't.
Thank you, John. I think we'll take some of the question and consideration from the participant. So be aware to take note, and then if there is something that we might need to clarify, you can clarify also. Thank you very much. Ok, caro participantes, tivemos aqui duas apresentações e vamos observar o intervalo quando forem 12h30. Vamos ter a oportunidade agora de podermos contribuir, questionarmos também, se for o caso, de termos algumas questões, que é para o Andrew e o John poderem tomar nota. Algumas que derem para esclarecer antes do intervalo vão esclarecer, mas aquelas que julgarmos que precisamos de mais espaço depois do almoço, vamos continuar a amadurecer e também a partilharmos aquilo que é a nossa visão em relação a estas duas apresentações que foram aqui proferidas, uma pelo Andrew e a outra pelo John. Por isso, participantes, questões, a sala é nossa. Já calado, faz favor, comece. Depois nós outros vamos seguir.
Ok, obrigado, senhor
Pela
diretor.
hora, né? São 12, então estamos a sentir aí um bichinho. Mas pronto, vamos contribuir, vamos adicionar valor a esta documentação.
Obrigado, senhor diretor. Dois pequenos comentários, talvez esclarecimentos adicionais. Primeiro para o John. No exemplo que ele deu, nas análises que foram feitas, eles fizeram a análise do stress e strain no topo do subgrade. Ok? O que eu queria perceber é, vamos supor que tenha sido feita essa análise no topo do subgrade, mas podia-se também fazer análise no meio, por exemplo, da base e no topo da base. Os resultados que ele conseguiu obter seriam os mesmos se essas análises também ao nível do meio da base e no topo da base tivessem sido feitos. É esta a principal pergunta que eu tenho a colocar. E a segunda questão é que volto para a questão do super single. A análise que foi feita foi considerando duas rodas, com área de contacto de 105, a pressão de 577 e tudo mais. Mas com o super single as condições mudam. Qual poderá ser o impacto do super single se nós fizemos a análise com uma configuração diferente, em termos de pressão e em termos também da área de contacto da roda e do pavimento. Obrigado.
Penso que o John captou as duas questões que o engenheiro Calado colocou para esclarecimento. Podíamos tomar mais duas, talvez aí podiam esclarecer e voltávamos depois do almoço. Mais questões, mais contribuições, colegas, participantes? Engenheiro Rangel, engenheiro Celso, engenheiro Caimán. Estou a fazer aqui provocação. Às vezes vale a provocação. Engenheiro Celso, faz favor.
Na verdade, eu não queria responder à provocação. Eu queria contribuir a dizer que, olhando para aquilo que foi Sim, seu diretor, muito obrigado. Eu dizia que eu não ia responder à provocação como tal, eu queria contribuir pelo seguinte. O Dr. Rolf falou rapidamente sobre CANPAV. CANPAV é um software de análise de solicitações que tem muitas considerações em relação aos outros normalmente utilizados como o LSIM e o Chef 15. O CANPAV considera, para além das funções, o CANPAV considera, para além das funções de transferência, considera se ou não uma camada está colada em relação à outra. Se as duas camadas estiverem coladas ou não, aquilo que é resposta é diferente. Então, quando se faz análise com o CANPAV, é preciso saber exatamente o que é que nós estamos a pôr nas camadas e ter em conta aquilo que é o method statement. Porque nesses moldes, o CANPAV, para além de considerar se entre uma camada e outra há uma ligação aparentemente monolítica, ele também considera o tipo de ensaios e resultados com a respectiva fiabilidade. Por isso, a resposta do engenheiro Calado pode ficar minimamente ajudada a responder a segunda, que refere, a primeira que refere sobre o ponto de leitura, porque a zona de leitura depende do tipo de camada e normalmente depende daquilo que nós queremos medir. Em relação à parte relacionada com o catálogo, eu ainda me lembro de ouvir dizer num dos seminários, acho que foi em 2013, com o Dr. Roth, em que o Kenneth Mukura dizia: temos de ter cuidado com a análise dos catálogos, porque eu posso considerar que todas as estradas de Moçambique são low volume roads, porque normalmente nós não vamos acima dos 10 milhões de eixos padrões equivalentes. O Otto fez uma demonstração com 51 milhões, acho que é muito boa, acho que o catálogo já vai muito além daquilo que são as nossas expectativas para os próximos 20 anos, porque até 30 milhões poderemos ter eventualmente na N4 com aquilo que são os autocarros. Em relação ao Super Single, não sei se eu posso ajudar a consideração. Se poderia dizer o seguinte: quando nós fazemos análise no software de uma roda, duas rodas ou mais rodas, porque nós quando formos analisar o pavimento para a aviação civil, nós consideramos a estrutura do avião e escolhemos uma das rodas como eixo. Mas aí já fazemos análise de várias rodas. A consideração entre o Super Single e o W e o eixo duplo é que o Super Single tem uma área de contato maior, tem uma capacidade de carga maior está a ser considerado o maior problema não é o fato dele ser com área de contacto maior ou ser com uma capacidade de carga maior. Os pneus em si, quer super single, quer com eixo duplo, estão a ser considerados mais agressivos pelo fato de quando começaram a surgir aquilo que são os tubeless, sem câmara de ar, aquilo que é a estrutura lateral do pneu é mais rígida e provoca maior carga de corte no pavimento nas zonas limítrofes, nas zonas terminais. Então, o super single e os outros são analisados do ponto de vista quer da pressão, quer do raio de contacto, área de contacto, quer da carga por cima. Mas o maior problema não é o super single ou o W. O maior problema é o aumento da qualidade, a melhoria da qualidade da borracha com o aumento de capacidade do pneu tubeless, que faz com que a carga de faca, entre aspas, nos bermas seja maior que na zona central de apoio. Obrigado.
Obrigado, Engenheiro Celso, pelas considerações. Já estou a ver que o debate está a animar. Estamos a entrar nas características do equipamento rolante, que neste caso são as viaturas, do ponto de vista dos pneus, e por questões mesmo de tempo, vamos continuar a nossa discussão depois do almoço e a devolver a palavra para as considerações finais, dadas essas duas questões que a Engenheiro Calado fez, ao Andrew e ao John, que é para tecerem algumas considerações antes de irmos ao almoço. 5 minutos apenas, senão a comida vai esfriar.
Yeah, can somebody on the Zoom team ask John to respond? Okay, in the absence of John responding, let me attempt to answer a couple of questions that Engineer Calado raised. I couldn't get the full question of Engineer Celso because my headset keeps cutting out. The first question raised by Engineer Calado was that if the analysis, the mechanistic analysis had been done and the stresses and strains had been considered in different layers rather than only on the subgrade, say in the middle of the layer, couldn't the result show that the pavement would carry a different a different traffic than the values presented by John? And the answer is yes, that if you consider all the different layers, you will find different stresses and strains, and each of the materials has got its failure point. Different materials can take only limited levels of stresses and strains, and some of them will fail. So in the RN31, in the Appendix A, we have provided the failure criteria for the different materials, the asphalt layer at the bottom, if bottom up, the subgrade layers where they'll fail from, and cemented layers, what their critical stresses and strains are. So again, in CanPave, the software that John talked about, it's capable of modeling and determining the stresses at each of those levels for each of those materials. It's a free software. We're not selling it or anything. It was made by University of Kentucky. Very popular with university researchers because it's free and simple. You can determine those stresses and strains there and plug it into the failure criteria which are in the road note and in other documents, and you'll find what is the limiting traffic that it can carry to failure. There's also a popular tool, web-based tool from South Africa called Rubicon. You have to subscribe, I think, free of charge. They allow you limited analysis, but if you want more analysis, you subscribe for a year or so. And those are all capable of determining stresses and strains and failure criteria. So it matters, especially I think here in Mozambique where you use a lot of cemented materials, it's good to check the cemented layer as well, because that could be the critical layer, not the subgrade, not the asphalt. Good to check that. There was also a second question on the issue of, again by Engineer Kalada, what the result would have been if super single tire or a single tire was used as opposed to the dual tires that John showed. And I think Engineer Celso attempted to explain that or explained it, but I couldn't get the translation clearly. But certainly the result will be different. Super singles, when you model them on some of these mechanistic models, in fact, before I say that, if you go to Google and you search the effect of super single tires, you may get, if you sample, say, 10 papers or 20 or whatever, you'll get half of them saying super singles are very good for pavements. Then you get another half saying super singles are terrible for pavements. So you'll get lost there. But my own assessment in the modeling software is that they'll show very high or higher stresses on the upper layers, but lower stresses on the lower, at the subgrade level. So they definitely have, I think, an effect on the surfacing layers, especially. They're going to induce cracks quicker or wider. And indeed, that is one advantage of doing a research within your road network to see whether roads that carry predominantly super singles are actually inducing cracks wider or slower, and then being able to actually calibrate in any mechanistic modeling that you do to account for that early failure so that you choose the material appropriately. I think my 5 minutes are possibly over. Thank you.
I think we'll continue with the discussion later on. Quero com isso agradecer esta primeira sessão aos participantes. Penso que tivemos aqui a indicação do que é o RoadNet 31 e também duas apresentações que foram proferidas aqui. Tivemos agora a oportunidade desta interação, que foi para esclarecer algumas questões que foram levantadas, mas penso eu que a discussão não esgota com este esclarecimento. Vamos continuar com este debate, com essa interação, que é para aquilo que não estiver captado dentro deste documento, seja captado de forma apropriada e esteja lá refletido. Dito isso, colegas, vamos já ao almoço, vamos observar o intervalo de 1 hora, é isso, em calado? Sim. E voltamos quando forem 13h40, 13h30. Estamos um bocadinho atrasados, 13h30 voltamos para retomarmos as nossas atividades. Dito isso, colega, bom apetite a todos. Penso que a organização protocolo vai nos conduzir até o local da refeição ou do almoço. Obrigado.
Perguntas relacionadas com as duas últimas apresentações que foram feitas pelos consultores e deixou o recado de continuarmos a discutir qualquer assunto que os colegas queiram levantar para a devida explicação por parte dos consultores. Desta forma, abro espaço para qualquer pergunta ou comentário que os colegas queiram fazer em relação às últimas duas apresentações que foram feitas pelos consultores. A sessão está aberta. Obrigado. Uma questão que queremos apresentar. Enquanto estamos a pensar, vou pedindo ao apresentador para responder a algumas questões que foram apresentadas na primeira parte. Obrigado.
Okay, there's some questions that came through on Zoom. They've sent them to me, and I'll answer this. Then there were two which we had left from the morning, which I'll also try to address. On Zoom, somebody asked, he said, this is regarding the testing of subgrade material, said, how do you know that the swelling has stopped? And the answer to that is quite simple. Usually when you're soaking your samples for CBR testing, you're going to have a dial gauge which is placed in the mold and on the swell, on the surcharge plates, and it will measure the movement, which you can record every day at a fixed time. You go and record and see whether that movement of the gauge, of the dial gauge, has stopped, and that is when you know that the swell has stopped. Or if the movement is really, really negligible, then you know the swell has stopped. There was also a second question that said, also the CBR at worst case moisture still doesn't make sense to me. I'm guessing here that the question is directed at the ability to test the CBR at other moisture contents other than the worst case. So I'll re-explain what I'd explained in the morning, that yes, in reality, if you go right now on a road somewhere and you check the moisture content of the subgrade, it may be even below the OMC, which is not the worst case scenario. But if you are designing especially critical roads, like trunk roads, you're designing for a period of 20 years. Now, a trunk road is a very critical infrastructure that if it's cut off even for a day, the economy suffers significantly. Now, you don't want the chance in this 20 years design life or 15 years design life that at one point, if you designed your road on the basis that the moisture will only be at, say, OMC, or the optimum moisture content, you don't want to take that risk, because within the 20 years or the 15 years, at least one day or 1 week or 1 month or whatever, there is a chance that that moisture in the subgrade, whether due to a storm or a flood from somewhere, that moisture is going to exceed the threshold that you have designed for at OMC. So you are taking a risk management action by designing for the worst case, because the infrastructure is critical. And because of that, you use a 4-day soaked or soaking until swelled, so that so till no further swell, so that should this happen to your road, you know that the road will not fail catastrophically or suddenly as a result of this. There was also a question again from Zoom, which asked, is hot rolled asphalt used outside United Kingdom, and how is constructability and performance compared with the typical asphalt concrete? Now, hot rolled asphalt, it's not very common outside the UK, and that is why in the road note we have put asphalt concrete and the wearing course stroke hot rolled for some of the catalogs where we are allowing for the fact that you're trying to build a flexible layer on the top. Now, generally speaking, if you use the same type of bitumen, asphalt concrete would be stronger than hot rolled asphalt. But in the design and construction of hot rolled asphalt, the binder is usually stiffer or stronger, and there is a high sand matrix to provide or compensate for that strength. So unfortunately, if this is subjected to high temperatures, it will perform worse than asphaltic concrete if it's subjected to very high temperatures or poorly constructed or poorly designed. But there are cases where it's applicable. For example, if you're using it on top of a dense bituminous macadam, so the strength is being provided by the dense bituminous macadam, or if you're using it as a comfort layer, that means you're providing for not strength, but for the comfort of vehicles that are using the road, and the strength of the road, of the pavement, is already provided by lower layers. So that is how it compares with AC, and that's how it's used. And then the last question, which has come through to me from Zoom, is that what about long life pavements? Shouldn't we consider their inclusion? So long life pavements, I tried to explain in the morning, is a principle that if you design your pavement for, say, up to 80 million standard axles, some authorities take it as 50, others as 80 is the highest I've seen, that at that point, if you try to design for, say, 100 MESA using the same design principles, it would require that you put a thicker pavement than what you had at 80. But if you check the strains in your subgrade or in the pavement layers, for the one at 80, the structure that you have at 80, and the structure that you have for 100, there will be very little difference in the critical strain. In other words, if the subgrade was to fail at 200 microstrain, you could find that in the structure for 80, the strain is something like 150. Then in the structure for 100 million, the strain could be 140. So these are minor differences. So you find that the strain in the structure is now so low that it's not going to cause a failure of the subgrade or another layer. So you can now decide that actually the same structure that's working at 80 MESA is also going to work at 100 MESA. So with this explanation, we have considered it in a way by stopping our maximum traffic at 80 MESA, because we know that after 80, it is still going to work even way beyond. The other consideration for tropical countries is that by the time you reach at 80 or more than 80, the environmental effects or the climatic effects would have caused your, especially asphalt layer, to crack by that time. So you would have had to already intervene by changing something. So it does not become economical to go way, way beyond, but that is how it is considered. There was a couple of questions as well from the morning, which we hadn't addressed. One of them was to do with the issue of hydraulic road binders. So hydraulic road binders are considered in section of chapter 5.8 and 5.10 of the RN31. And in brief, hydraulic road binders are basically products of cement industries or cement factories. And nowadays, in most parts of the world, including many parts of Africa, if you go to the cement factory and you say to them, I want a hydraulic road binder, they can make this for you. And what does that mean? It simply means that some constituents of ordinary Portland cement that we use are replaced with others. For example, they will introduce things like fly ash into the cement mix. They'll introduce shales or pozzolans and make substitutions, plus some other additives. What are they doing? Why are they doing that, you may ask? They're doing that for two main purposes. That they know that in road construction, it takes time from the mixing of the cement to the final compaction. So they do that to increase the working time that you can work with the cement. And the second main reason they do that is to reduce the shrinkage cracking that occurs in with ordinary Portland cements. And some cases, literature is reporting 40 to 80% reduction in shrinkage cracking that occurs. So if you have a crucial project, you can actually go to the cement factory and say, look, I want a hydraulic road binder. I need to minimize shrinkage cracking, and they will provide appropriately. We have also included in section 5.10 processes of minimizing shrinkage cracking during construction with cementitious materials, how you can minimize shrinkage cracking. The second question, which we've carried over from the morning, is to do with the issue of super single tires, which keeps coming back again and again. I'd attempted to answer this, but if someone can project my screen, please. Yes, so the table on the right represents the standard axle loads, which are used for various tire and axle load configurations, and axle configurations, tire and axle configurations. Now, this table is adopted from practice in Australia. It's being used by India, Nepal, some other countries are using the same table in recent times. And research has led to the understanding that the different tire types and axle configurations affect the pavement layers differently in terms of stresses and strains. So as a result of that research, they have come up with what they consider standard axle loads for the different axle and tire types. which are shown in this table here. Of course, if you are dealing with dual axle, as is the case in the second row here, the second row here with a value of 135, you will find that you have to consider the axle loads on both axles. So if you have 10 and 10, it's going to be 20, so 10 plus 20 over the 13.5 that you'd have there to deal with your dual axles. And then you apply the damage exponent, which is on the table to the left of the screen. So this, in a way, allows you to account for the effect of super singles and other tire configurations. Now, with the use of spreadsheets and software which are now available for traffic estimation, you can quickly compute the design standard axles which are used with all of these configurations. I must say that there is a school of thought which differs from this, and that's coming from the South African manual. And they say, okay, this happens, but because our traffic ranges are large, for example, you have in the catalog a range of 30 to 50, 50 to 80. They say it will not take your design traffic outside the range if you had simply just used a standard axle of 80 kilonewtons. So there are two schools of thought, but we think that with the increase of super singles, this is the way to go about it. So those were the questions that were so far captured on this.
Ok, muito obrigado, Andrew. Não sei se há mais alguma questão que queiram levantar em relação às duas primeiras apresentações. Se não houver mais nada, eu tenho mais umas duas questões. A primeira tem a ver com os catálogos que foram aqui largamente apresentados. O que se nota é que estes catálogos sempre apresentam debaixo da camada de superfície uma camada granular. Ok. Há alguma razão específica para tal? Em nenhuma das situações nós temos exemplos no catálogo de uma camada hydraulic bound material debaixo da camada de superfície. Ok? A segunda questão é qual a diferença entre hydraulic bound material e hydraulic modified material? Obrigado.
Okay, thank you for those questions. Very, very insightful questions. And the first one is the question of why is there no layer of hydraulic bound material under the asphaltic layers, and they're always granular layers. To answer that, up to, I think, catalogs up to A1 up to A3 or something like that, we do have, but it is limited to 17 mesa. So now, the main reason why we are not putting it there is because of the risk of cracking in service. That if you have especially thinner asphalts sitting on top of these hydraulic bound layers, the stresses are mostly going to be, the traffic stresses are mostly going to be carried by the hydraulic bound layer. And that means it's going to trigger your maintenance earlier than what you'd planned. So if your maintenance was supposed to occur, say, in year 15, your cracks could induce as early as year 10 or something, because much as with the modern materials with hydraulic rod binders, you've reduced shrinkage cracking, the cracking that occurs as a result of traffic stresses are still there. So it's going to still onset earlier if you have if you have only cement bound material under this thin asphalt. Now, but we have not forgotten the challenges faced by many countries. So in the notes, unfortunately, probably doesn't come out very clearly. In the notes on the catalogs, it allows you to actually modify this material further and use what you commonly use in Mozambique, like emulsion treated sand bases, which have got some cement in and some bitumen in, and that cuts out it reduces the onset of these shrinkage cracks quite significantly. Sorry, the onset of in-service cracking quite significantly. So, and that is how we have dealt with it. The second question was the difference between hydraulic bound material and hydraulic modified material. So at some strengths, I think in RN31, what we're calling CB3, we call it modified because the strength is so low. It's only, I think, 0.7 megapascals compressive strength. It's quite low. And in other cases, you're actually using the modification to mean that you have applied the hydraulic substance like cement to reduce the plasticity of the material. But in service, the material still behaves like a granular material because the granular particles have not been held firmly. They have not been bound. They have not been cemented. It's just the plasticity of the fines around the granules that have been reduced. So the material still behaves like a granular material rather than a bound material. So that's basically just a terminology, really. But technically, a cutoff value of about 0.75 megapascals is the range. Yeah, I think that's my response.
Ok, obrigado. Mais comentários, mais perguntas? Para os colegas, não sei se percebemos muito bem a explicação que ele deu em relação aos catálogos. Eu sou um dos técnicos da ANE que não gosto muito, apesar de nós estarmos a fazer muitos pavimentos com a base em cimento. Não gosto nem tão pouco de pavimentos com base em cimento. Eu levantei esta questão para podermos perceber melhor, todos nós, o que é que realmente acontece com as bases em cimento. Foi uma explicação que eu acho que é muito boa. Ainda bem que está aqui o diretor de manutenção, deve ter percebido melhor o problema que existe com este tipo de bases e os desafios que este tipo de bases trazem, principalmente para a manutenção. Isto é muito importante. Em relação a esta questão de bound modificado, é também muito importante, porque é preciso que nós percebamos até que ponto é que a mistura de um material com um outro elemento para a melhoria das características desse material, posso dizer que é um bound, é um modificado. Depende muito das percentagens que a gente coloca nos materiais que precisam de ser melhorados. Então, eu acho que isto é muito importante e temos que ter muito cuidado em relação a estas matérias quando nós usarmos estes instrumentos. Penso que não há mais perguntas em relação às apresentações que foram feitas e vou convidar o próximo apresentador para apresentar o tema sobre a resiliência climática das estradas. Obrigado.
Okay, good afternoon. My name is Manaye Unetu, and I will be presenting the payment, drainage, and climate resilience today. I think drainage is the most critical factor, and planning, design, and construction of a payment. And before embarking on the drainage on the road design, payment drainage should be considered. This is very critical. What Andrew was talking this morning, material strength, if you don't have proper drainage system, that will be lost. Now, moving on, having said that, I move on the outline of the presentation today is background and scope of the chapter, followed by adjusting the hydrological design standards, and then in the face of changing climate, and then climate resilience road drainage system, which is the core of this chapter, protection from damage from extreme rainfall events, which I think is a major problem here in Mozambique and other countries as well. And then drainage in problem soils, although this topic has been dealt in chapter 3, but drainage has also a major role to play, so I will be discussing this. Then sustainable drainage system, SARS, as a climate adaptation strategy. Sustainable drainage system is the drainage engineers, highway drainage engineers, traditionally the main aim is just to get rid of water from the pavement, and no consideration what it does to the local environment. And because of the legislations, now many countries are now putting stiff legislations, and people are becoming aware about the environmental impact. So even if you design it, you might not be able to construct it, so that needs to be taken into consideration. So in climate resilient drainage in difficult terrains, that's another issue, has been an issue for a long time, but with the climate change, it is becoming even exacerbated. And then critical drainage issues in sloping ground in mountainous areas. So Mozambique is not a mountainous area, but other countries like Ethiopia. And then I will summarize with the key points to take away with you. Now, the previous RN31, the fourth edition, contained very little information regarding drainage. It was only 2 pages. And we have actually written a new chapter by including or building upon to include information how to build climate resilience into the road drainage system so that the payment becomes robust and functions sustainably. Purpose and the scope of this chapter is not to give a guidance on pertinent design principles that can enhance climate change, but it is not intended to serve as a hydrology and the drainage manual, because that has been dealt with hydrology and drainage manual. This is not about how to estimate the flow or how to size the hydraulic structures like culverts, bridges, or ditches. It's just simply a design principle how to embed climate resilience into the road payment system. That's what it is, but it does not cover detailed hydrology and drainage designs, as this can be found in specific manuals, which is, for example, in Mozambique's hydrology and drainage manual. So for this detailed design, you need to refer to that manual. But this document is a supplementary guidance document which fills the gap, especially on climate change, because the manual and other policy documents, they based on stationary climate assumptions. It doesn't take the changing climate into consideration. So the main purpose of this chapter is just to embed climate change. Now, adjusting hydrological standards. Why do you need to adjust hydrological standards? For example, climate is changing. There is an increased precipitation in flooding, which affects the design standard, cross drainage structures, and it is not uniform. It's uniformly increasing or decreasing. In some places there is a wetter, and in other places it is less. So there is no one solution to fit all for the problem. So it has to be checked and designed, and region by region, country by country, even within the same country, it has to be looked at in a site-specific manner. And then there's a change in timing of a wet or dry season as well because of the climate change. That needs to be considered. And the other issue is the sea level rise and associated storm surges, which is affecting coastal roads. I think Mozambique has a long stretch of coastal lines, and that needs to be, I think, embedded in there. Then the other is increase in river flows, which is significantly affect the design of bridges and the bridge abutments as well. So the standards which are put in place with the traditional design needs to be revised. Now, in adjusting the hydrological standards, the rainfall intensity used to calculate the design storm must be adjusted to include the effect of climate change. As I said before, traditionally the assumption is that when you calculate, for example, your IDF curves, you assume you're taking the historical data and then trying to extrapolate to predict the future, assuming the stationary climate, which is assuming the climate is not going to change. And that type of assumption is insufficient, is not valid. So we need to adjust that assumption. That means there are two options. The one option is as the precautionary approach, which is add an allowance for climate change, which is a single figure based on the targeted year. This is based on research in the UK. And the second one is adjust the climate change effect based on the climate emission scenarios. This means in option one, precautionary approach is just generally recommended for fluvial rivers flow in the context that a single climate change allowance of say between 5% to 30% additional flow is applied to the estimated present day scenario, what we have. Say, for example, if you are designing a bridge or a crossing for 100 year peak flow, then you add a certain percentage based on the design life of that particular road. Maybe for payments 20 year, 30 year for 250 year for culverts, and maybe 100 year for a bridge. Then recommended in UK at the moment is for 1990 to 25, you add 5%, and then 25 to 55, 10%, and then 55 to 85, 20%, and then 85 to 21, 15, you put extra 30%. That's for the peak rainfall intensity. But for peak river flows, we do the same, but the sea surface water rise, we're expecting it to rise by 10 centimeters, 15, 25, and 35 centimeters. Now, when we wrote the Mozambique manual at that time, everyone was adding or uplifting the intensity by 20%. But after that, that has been improved now. It has been targeted by design a certain periods, which is the design life of the infrastructure. So that is what you need. If you have what we're going to go on the option 2, regionally or locally available climate change models, then that is the exact way to do it, the better way to do it. But if you don't have that, locally available models, climate circulation models, then you can use this. You can uplift your design drainage structures by this one. So that means you are not underestimating or you are not losing capacity and get flooded. The second option is adjusting based on the climate change scenarios, which means the projection from selected model data for short-term, medium, and high emission scenarios for climatic values relative to the baseline over the forecast useful life of the pavement drainage system, say 30 years period. Then you can take the model from a global model, or if it is regionally available from your regional model, and then you take it for the short term, say the same thing as we did on the precautionary approach for 30-year interval period, and then add that exact value. So you might know the percentage varies because that is the based on the emission scenarios. So the percentage might not be 25, it might be 15, or in some areas it might be negative. So that's what we need to do. But the problem with the global circulation model, as the name implies, they are global. Global means you are dividing the, as you look at that red lines, the grid, the world into little boxes, which is a hydraulics modelers. If there's anyone in here, numerical modelers know when you do, you just divide into little grids and then you calculate within that grid. So the size of the grid, most of the global circulation models is say 250 by 250 kilometers, which is very, very crude and very coarse. That means the assumption is within this grid, the variation of topography, the proximity to water bodies, and the rainfall distributions, you are assuming will become more or less similar, but in reality, it is too crude. So what you need to do is you need to downscale this model, which means you need to take the output from the global circulation model and down scale it, which means with a high resolution grid, let's say to 20 kilometer grid, or 12 kilometer grid. In UK now, we are working on 2.2 kilometer, which is very, very fine grid. That means you can capture, because climate change is also driven by topography as well. So if you have mountains, river bodies, it can be captured with the high resolution grids. So, and the other issue with global circulation models is there are many models which have been developed in several countries by different organizations. The output is sometimes means the surface temperature and the pressure. So for the drainage engineers, they need a precipitation, the intensity. So you need to do a linear correlation between the two, and then taking that to predict your rainfall intensity or precipitation. So you need to be careful when you are using the global circulation models, unless you downscale it locally. If you have a locally available circulation model or regional climate change models or site-specific models, then you take that and calibrate it and verify it with locally observed climate data, and then that will give you a better representation. So when you look at all the policy documents in relation to drainage, like a flow estimation, like the IDF curves, and the specifications, they are based on stationary climate. So you need, that needs to be revised and adjusted to take the climate change into consideration. So you might be even, manuals are living documents. They have to be revised at least every 2 to 5 years. So if you have a drainage manual, that needs to be revised as well to take this into consideration. Now I will move on to the climate resilient road drainage systems. There are two types of drainage systems: the external surface drainage and subsurface internal or subsurface drainage system. The external drainage systems, they are already taken care of by the hydrology and drainage manual, but these two needs to be, although the pavement drainage is mostly concerned with internal drainage, but the two, the subsurface, external, internal, needs to be integrated. So unless the surface drainage is just to get the water removed as soon as practicable from the road surface, that means the water coming from the surrounding areas needs to be intercepted before it reaches to the road. And then the rain which is falling on the pavement has to be drained as quickly as possible. And all this needs to be taken care of by external drainage systems. So, and if we don't remove water as quickly as practicable, the water can ingress into the pavement layers in several ways. And some of these are the surfacing, which is Andrew was talking this morning, due to oxidative hardening of bituminous layers, and the cracking of the surface is one way of the water can ingress into the pavement. And the other one is through the joints of modular pavements, and it can get into cracks in the concrete and weakens the top areas, which is the high stress zone. The other area that water can ingress or enter into the pavement is through unsealed shoulders. So water easily penetrates and weakens material below the wheel path, which is again the high stress zone. And then the other cause of ingress into the pavement is crown height. It's a low crown height. And the other one is side ditch. If invert level is not designed correctly, water can laterally enter into the pavement structure. So these are a couple of photographs which I put in there. On the left, you see the severely eroded earthen shoulder of a concrete road. When you look at here, it is quite open, quite been eroded, and the water can easily get into the pavement layers and just destroyed. On the right side, you see a very limited erosion seen on the shoulder constructed with a granular material, although it is still trying to fade away, but it can be put back in place with a little maintenance. So that's the material I think it's advisable not to use if the economy or the budget is there. Instead of using earthen shoulder, you better use a granular or sealed shoulders. Now the other problem area with external surface drainage is not having a ditch. In some roads, the ditch is missing, and on the left you see the grown high grass there, which is stopping the water from being drained, so obstructing the surface flow, which is showing the photograph on the right. And then what it means is the water can penetrate through the edge of the pavement and then weaken or deforms and misses the bearing capacity of the road. So it is always better if depending on the topography of the area and the rainfall and the importance of the road, to put a ditch on both sides of the road. Now, how are you going to prevent surface water from entering into the pavement layer? Well, as I said before, adequate crown height and ditch invert level is one way of mitigating that problem. And then if you have a standard crown height in the manuals, then in the phase of changing climate, you might be considering increasing that crown height. And then the other one is preventing ingress of moisture from pavement edge by sealing the shoulders or raising the embankment is one way of protecting the road. And then use impermeable seals such as OTA seals and cap seals. They will stop the water from ingressing into the pavement. And then undertake periodic maintenance. Maintenance is very, very key. If you don't maintain your road, then even if it is drainage is being properly done, it is going to be a problem. Now this is now we move on into internal or subsurface drainage, which is very important for the pavement drainage, which is subsurface drainage is the diversion or removal of excess soil water from the subgrade and pavement layers. So despite an efficient and function draining system, water can always enter into the pavement, and we cannot 100% stop water from penetrating. It can be from the edging of the road or other reasons which I mentioned before. So there's an example of a design or a construction system here, which is you have as in number 3 sub base and shoulder with different materials, which is permeable material. And in that case, if you have a permeable material on the top and impermeable downstream, down the bottom layer, then you are creating a boxed in trench construction there, which water can be trapped in there and then starts to weaken the bearing capacity of the road. So when you are doing that, it is better to put as in number 7 a drainage layer so that it drains off quite quickly without being trapped. The best approach to do is, if economy again, if the finance is there, is to extend the road base and the shoulder with the same material all the way to your ditch. That means the water can drain properly without being trapped. So that is which is shown in number 8, that needs to be in here, extended all the way to the ditch. So that's the better way of designing a drainage system. Okay. So how can you improve the internal drainage system? Well, number 1 is, as I did, avoid boxed in or trench type construction. That's the first thing. And then road base and sub base should be extended to the side drains. provide surface drainage systems such as French drains, interceptor drains, filter layers, or drainage blankets, and then prevent permeability inversion. I would like to say something about permeability inversion is that when you have drainage layers, the permeability is decreasing downwards, then that's we are going to have a permeability inversion, because in reality, the permeability of the layer should increase downward so that you're not blocking the vertical drainage. So you need to avoid that. Now I will move on to protecting from damage from extreme rainfall events, which is climate resilient, that is which been included in section 7.4. I think now because of climate change, we are seeing closure of roads and washouts, frequent washouts of roads and closure, and because of that, we are it's a loss of economy and interruptions in transport systems, and that is becoming a common occurrence. So we need to have climate resilience drainage to protect the road from being washed away. A washout is a result of a combination of flood and erosion. For roads that are near stream banks, they are the most affected, or that are running across the streams. Severe erosion may cause a washout of the road. Can be the bank being eroded, or the culvert being blocked by debris because of climate change, and the bridge abutment can be also badly affected. As I said, blockage of drains due to poor maintenance is one cause, as well as inadequate drainage capacity, because as I talked about, the drainage standards that we are putting at the moment might not cater with the increased climate change impact. So, or the extreme event can lead to washout, torrential rains or cyclones. They cause washout of the road. Extreme rainfall events can cause washout to occur more frequently, as they generally entail heavy downpours of rain within a short period of time. So I mean, the short, high intensity and short duration rainfalls are very, very problematic. So they need to be carefully looked at. So sea level rise will result in coastal flooding being more extreme due to the high base levels. And the other one is increased salinity of coastal rivers waters with a related impact on short salt sensitive structures. I mean, if you have a concrete structure around the coast, that might be affected by salt water as well. And then increase in sedimentation in tidal areas is another problem as well. So the water cannot escape or drain properly into the sea. Now we need to distinguish between washout and inundation in here, because washout, the characteristics to failure and the type of payment is different. It is resistance to washout is different, or its impact between the washout and inundation. So the washout, rapid flow of water with a high current, occurs in the washout, the payment structure. So the type of payment in this situation doesn't matter that much. But when it is, a road is inundated with water, then the payment type has an impact, so which I will be talking. Now I'm just going to show you a video which has been recorded live when the road has been washed out, the culvert structure has been blocked, and it's just washed out. No. You can see the trees have been uprooted, and initially the water starts to flood on the road pavement, and then it starts to erode on the upstream side of the culvert, and the trees have been uprooted by high current and going to the culvert, which is choking the culvert. And now the water starts to erode the upstream side of the culvert. So you need, this is to do with maintenance and lack of capacity of the culvert. So there's a combination, and there has not been a detailed investigation on this, whether the material quality has also an impact with it. So now no water is flowing on the road. Now it's just eating below the pavement, the subbies and the subgrade are completely gone. So the road is wrangling before it falls down completely. It starts to fail from the shoulder and progressing to the pavement, and then now it's completely gone. Yeah, it's gone now. So if you just wait a couple of minutes, it starts to fall and even widened. The gap is gone. It's just once it is washed out in one location, it continues to fall apart. So that's happening now from time to time because of the climate change, and the intensity, duration, and frequency of rainfall is increasing. Now, yeah, if we go to a couple of minutes, it's just continue to fall. It's just, it becomes very wide. So that means there's interruption, and putting it back, it takes some time. So it is the culvert, the metal culvert is dangling in here. So one of the climate resilient is that the road needs to be prepared for, and then be able to recover quickly and adapt to this type of scenario. So if we are anticipating this type of scenarios during planning, we need to be able to put it back in place into operation. This is another example, which is here in Mozambique, which I took these pictures a couple of years ago in the Chisamo Chiputo section of the N22, which is, I think, badly damaged by the December 2012 and January 13 flood, which is, as you can see here, it's a similar culvert actually. I think the metal culverts are becoming problematic now. They're not used anymore now. I mean, they are used, but we are now moving into the monolithic concrete culverts rather than these ones. But you can use them in areas where you have salt water. Otherwise, this is really not being used anymore. So they are, unless you anchor them properly, they are very prone to being washed out. So this one, when I visited it in here, there was an argument saying, oh, it's a geological issue. But the way I see it, this was overtopped, and the water starts to erode the downstream side of the road, and then it gave away. There is people are not distinguishing between the hydrodynamic and geotechnical failure and the overtopping failure. The hydrodynamic and geotechnical failure is that when the water starts to pond behind the embankment acts like a dam, and when the load becomes greater, then it starts to fail before it overtops. That is the hydrodynamic and geotechnical failure. But the overtopping failure, it starts from the bottom of the embankment. When you look at the road over here, you see that the road, which is not which is still not been washed out, but the downstream is still visible, being eroded. So this road has failed, the way I see it from overtopping. So I was talking, I think this lunchtime, I think I'm glad you have a flood map. That's very, very critical in these areas. You need to have a flood map so that you know the velocity and the depth of the water coming in there so that you can protect your embankment. This is another example of undercutting and collapse of a pavement due to erosion of embankment, which is similar as well. You can clearly look at it. And the other area that a pavement can be washed away is when you have a road which is running parallel to a stream. That way, again, there will be a combination of flood coming from the upstream in here, from the hillside, and then another one is the erosion from the river bank itself. So it starts to erode the shoulder and then progress into the main pavement and the road collapses. This is also a collapsed coastal road, which is again the effect of the sea level rise and the wave from the sea, which is destroying the road. So that are the areas you need to be cautious. Now, how are you going to mitigate this? Well, one of them is just do a site-specific flood risk assessment to identify which area, because you're not going to provide for the same type of protection for the whole network of the road, but you need to identify which road is more will be more affected by changing climate, so that you can give a specific for that specific network the protection measures. And the other one is early assessment of climate change is very, very critical as well in the design and planning process. For example, engineers, climate scientists, hydrologists, geologists, and stakeholders needs to come together and work collaboratively. But the traditional way of designing is that the alignment engineer fixes the alignment first, and he calls upon the drainage engineer to design the drainage. That is bad practice. So you need to have collaboration approach. And the other one is applying a safety factor, example, freeboard. When I talk about allowance for climate change, that's the difference from freeboard. Freeboard is you set your flare level and then add maybe between 0.5 or 1.5 meter according to the criticality of the risk. That's what you call a freeboard. The other one is solution is considering longer return period for exceptional events when designing hydraulic structure, because of a climate change, the 100 design event now might be a 25 design event in the coming years, because it becomes more frequent, and then we need to increase this as well. The other one is using a waterproof material or treating the material to be waterproof is another mitigation measure. And then reducing the gradient of slopes is also another solution when you design your embankment. If you just make it a little bit flatter, and that will also protect the washout. And then design for future flexibility, leaving extra space for future drainage structures is also very, very important. For example, we might need extra culverts in the future, or we might need to have a pond, flood storage pond along that road. So you need to have that flexibility in mind. Now, what the 4 roads which are running parallel to the river, you need to have stream banks can be stabilized through the use of, for example, gabions, riprap, or increased vegetation, depending on the velocity, or planning and design. So it's very, very important as well when you, as I said before, when you are selecting your route based on the flood risk assessment during the planning process, you need to assess whether, because the best design option is just to stay away from flood risk areas if it is possible by all means. So that has to be done during the planning and the design process. The other one is increase the resistance. Oh, 7 minutes. Okay. Okay, it should be increase the resistance of road structure to erosion, that is through selection of type of pavement or protection of embankment slopes, changing the elevation of the road structure, but it's not always, when I say changing, increasing, but decreasing and allowing it to flood is also one area you need to consider, and providing cross drainage structures of roads, for example, multiple culverts, and changing the alignment of the road and increase the distance from the water course. And then the coastal road washout protection measures include constructing levee banks with drainage or seawalls, construct seawalls, offshore breakwaters, ripraps to protect the shoreline from coastal erosion and submersion, planting artificial reefs. It's also placing a metal culvert with reinforced concrete, resetting of critical infrastructure from areas that are forecasted to be most at risk of from raising sea levels, developing coastal flood strategies that identifies the most appropriate shoreline management plan and assess whether coastal defense are required or needed. Now this is, I think Andrew showed this morning, this is one of type of protection works that you need. For example, this is the red line shows the road being overtopped, so you can have a dry paved stone over a layer of geotextile or suitable filter layers on the upstream side of the embankment with a flatter slope. On the downstream, you can have a concrete protection and with a sealing basin to break the energy as an energy breaker so that the downstream toe of the embankment is not washed out. And this is another area with drainage and problem soils, although it has been discussed in chapter 3 and it's a geotechnical issue, but drainage is also quite critical and needs to be taken because of the swelling and drying effect because of the moisture that needs to be also looked at. So this is already been quite detailed in chapter 3, so I wouldn't be talking that much. So we put there mitigation or remedial measures, so you can read from that. And this is another area you need to look at on this type of soils. Again, the slope, and then the zone of moisture equilibrium areas. And then you need to replace dry or clay with, for example, with inert materials. So material replacement, concrete ditches on both sides of the road, that type of protection is quite important. Now I need really to talk about sustainable drainage systems. As I said before, the traditional drainage is just to get rid of polluted water into the river, the receiving water course without taking sustainability in mind. Now, because of the environmental impact assessment, you'll not be allowed to discharge polluted water. So even if you design it, you're not going to be able to build it. Even if you build it, the local community will block. You find your culvert being blocked. So you need really to look at this very, very carefully. So the sustainable drainage system, it reduces the flood, improves the water quality, introduces biodiversity and amenity. So that's called road drainage system. So there are different types of sustainable drainage systems for the road. These are the main ones. You have soils, filter stripes, filter drains, detention basins, ponds and wetlands, and attenuation storages. This is a classical example. People might be saying, well, this is what is the difference between the ordinary grass channel or this one? You see, look at this bottom. You've got permeable layers, which stores. It can be used as a conveyance route. You can use it as infiltration. It filters the dirt out, and it also can be used as a detention. It slows down the flow and protects erosion downstream. So you need to have a scour check there as well. So the next one is infiltration basin. You can put it whether upstream or downstream. So you can drain the water into the grass infiltration areas, and then you can slow down the peak flow, and you can have a control device like a weir or orifice in the downstream, and then the dirt will be, or the pollution will be stored in the clean water, go to the water body. It's the same similar into the other swells. Now, the other one is climate resilient drainage in difficult terrains. That terrains in sloping, flat, and low-lying areas are very problematic already with the climate change, impact of climate change that's getting worse. So I think we need to consider, for example, in low-lying areas, either you raise the formation level above the water level so that your road is not going to be inundated, or lower the water table by installing longitudinal sub-drains or controlling capillary rise using granular layers. If it's expensive to build high embankment, then the alternative, and your groundwater is high, the alternative is just to use a capillary rise to control the flow before getting into the subbase, and use permeable materials in swamp areas, for example, filter mattresses, so that the water can play, because if you don't have enough gradient to discharge it, so that is the better way to use. So controlling seepage on the hilly areas, seepage is a critical problem, erosion protection and catchwater drains needs to be, I'm just running against the time, so that's why I'm just speeding up. Then the countermeasures, once the road is constructed, many of the problems in flat and low-lying areas are quite difficult to solve. So good drainage design begins with good route selection. Hence, possible it is important to avoid flooded areas. And then it's not possible, the following countermeasures needs to be implemented. This is how you raise your formation level, and with the protection measures both upstream and downstream. And this is the capillary control capillary rise. You have here a filter layer which is between 15 and between 115 300 millimeter thick, depending on the material size, and then it has to be below, not less than 600 millimeter below the subbase, and it has to be at least 200 millimeter above the standing water. So the material here can be rock fill material, as I said, so the water can play both up and downstream. So this is very, very important as well, which is not, you cannot find this in existing drainage manuals. And the other one is the hill areas. The biggest problems, there will be a sheet flow coming and major erosion. So you need to provide ditches and the catchwater drains as well, so that you can. And the other one is just control the seepage flow using perforated pipes. So you need to lower the seepage line by putting a perforated pipe and then transferring the water from upstream to the downstream side. So when both ground surface and impervious layers are sloping towards the road, seepage flow is a critical problem, and you need to look and then provide proper drainage. So I think the maintenance, as I said, is very, very critical, and you need really to carry out a periodic maintenance for the ditch, for the drainage systems. So the shoulders, the ditches, the surfacing itself has to be sealed periodically. Otherwise, even if you have a proper drainage system, that's not going to be working. So you need to do maintenance. So the key points to take away is a highway pavement geometry, surface drainage, and pavement internal subsurface drainage, climate, and soil properties all have a significant impact on drainage and have to be looked at. Consider adjusting hydrological design standard, and then consider implementation of the SARS for climate adaptation. And then special attention is required for the drainage of problem soils in difficult terrains. And then a resilient drainage system with an adequate capacity to cater for increased flows is critical for the integrity of the performance of the road. It's also important for decision makers to appropriately consider and account for extreme weather conditions during the planning, design, and construction phases of the road. Avoiding poorly drained areas, unsuitable mountain foundation soils, frequently flooded areas, and unnecessary stream crossing will greatly reduce the cost. So you need to stay away. Climate resilient drainage for roads in hilly and mountainous areas should be also considered. That will bring me to the end of my presentation. I hope I am in time.
Ok, obrigado pela apresentação. Como foi dito durante a apresentação, a versão anterior do Road Note praticamente não tinha muita coisa sobre a resiliência climática. E esta versão que nos é trazida hoje já tem em conta estes aspectos que têm ciclicamente afetado a nossa rede de estradas. Acho que é momento próprio para podermos colocar as nossas perguntas, colocar as nossas contribuições, comentários para quem os tiver. Então, colegas estão convidados a fazerem as vossas intervenções.
Obrigada, boa tarde a todos. Eu vou fazer um comentário e uma questão. O comentário primeiro é que muitas destas recomendações, quando falou de estratégia de mitigação, acabam recaindo sobre o projeto, sobre as diferentes especialidades do projeto. Então, seria uma recomendação para que, da mesma forma que está a ser feito com este documento, se pensasse em uma atualização das normas de projeto geométrico, porque penso que muitas destas questões podem ser evitadas ou minimizadas se nós tivermos em conta estas recomendações na fase de projeto geométrico ainda. E, sobretudo, esta interação. Podemos criar uma interação melhor entre o projeto geométrico e o projeto de drenagem. Passo para a questão. Muito se fala hoje em dia, em todos os fóruns em que se discute esta questão da drenagem da estrada e os cortes constantes que temos na época chuvosa. Fala-se de poder rebaixar o nível de algumas estradas, de alguns trechos de estrada, para permitir que a água passe por cima. Aqui voltou a se falar desta questão, mas existem custos envolvidos nisto e não é possível fazermos isto para todos os trechos problemáticos. Eu gostava de saber, em jeito de recomendação, em que trechos é que poderia ser viável este tipo de solução e em quais é que é viável que se continue a pensar em elevar o nível da estrada e continuar a adotar estas soluções de drenagem transversal que são tradicionais. Obrigada.
O engenheiro Celso pediu a palavra, né? Ah, ok. É que vi-lhe levantar o braço. Mais comentários, perguntas? Perguntas, comentários? Enquanto vão pensando, vou convidar o apresentador para responder à pergunta que foi colocada.
Okay. Thank you. I mean, in terms of integrating the geometry and drainage, we have included in there, for example, when you are talking about crown height, is geometry. And then we are also talking about the slope adjustment of the embankment. It's also part of the geometry. So the geometry engineer and drainage engineer should work hand in hand. So to answer your questions, we need to adjust the geometry in order to accommodate the drainage or to become more resilient. So if I get the question right, so the geometry of the road needs to be probably on the first section when I just adjusting hydrology, that is about hydrological standards, that's purely about hydrological standards. But when we are talking about surface drainage, we are also talking about the geometry of the road, because the crown height is part of the geometrical design. I'm not a geometry engineer, I'm a drainage engineer, but the two needs to work together. So we need to, when we are talking about the ditch level, crown height, and embankment slopes, all that drainage and geometry. So the two needs to work together. So that's the first one. In terms of the lowering the road, I don't think we should lower the road everywhere. It has to be where you are. For example, if you are in a flat area and you have a sag point at somewhere, so rather than, number one is, if you have a financial, you need to look at the environment. If that embankment is going to divide or fragment the floodplain, and sometimes people, they put a high embankment, you divide the community. If it is agricultural land, for example, so naturally the water is flowing, a sheet flow, less velocity, spreading all over the field, is not going to damage the crop. When you put an embankment in the middle of agricultural areas and put a culvert, what you are doing is you are concentrating the flow into a small passage, so that will create a gully downstream of the embankment, and it's also disturb the ecosystem because you have less water downstream of the embankment while you have flooding upstream of the embankment as well. In that case, it might be legally, farmers might even legally sue you destroying their crops. So in those areas, rather than raising the embankment, or you can't raise the embankment, or you can put several culverts so the water can pass through, or you do a superstructure. But if you have, for example, putting a high embankment is also very, very costly, and depending what is happening downstream and upstream of the embankment, and if you have a sag point, at some point the flow is not with a high current, so that you can lower your road, and then the water flow over it with a protection, of course. So you're not putting everywhere, so it has to be site specific, taking the environment into consideration, and then the economical aspect into consideration. So in some places you lower it, in some places you have a higher embankment, in some places you have an embankment with a French mattresses or fritter mattresses, so that with a clean rock, so that the water can play both sides, and that's good for the environment as well. So we are not recommending, we have recommended stage by stage. When you have this, you need to do that, and then you need to raise the embankment, and if the environment permits, you can also lower your road and then try to overflow. And if that is not even possible, and then you have a permeable subgrade, so that the water can place in swampy areas, for example. So lowering is one option, not a blanket option across the board, if that addresses your question. Because even if you don't lower your road, if that area is a critical flood risk areas, the road is going to flood anyway. So instead of raising, especially if it is in high current areas, rapid flow going in that area, so that will be threatened as well. So even if it is not failing due to overtopping, it's going to fail due to hydrodynamic and geotechnical issues. So you need to look at it area by area and then risk by risk basis.
Ok, obrigado. Mais comentários? Engenheiro Celso?
Meu comentário rápido é, se formos ver os manuais antigos, diziam claramente, como eu disse na das primeiras intervenções, que o nível máximo da água estagnada na plataforma da estrada tinha de ser meio metro abaixo. Para além de criar um elevado ou alto plataforma da estrada com uma altura muito grande, também faz com que a estrada tenha largura suficiente para aguentar a pressão hidrostática como se fosse uma barragem, o que faz com que a redução, ou seja, aumenta a velocidade de escoamento nas passagens hidráulicas. Então, eu acho que a decisão em termos de baixar a estrada, que é uma recomendação muito boa, não deixa de ser necessária a avaliação ambiental que é feita. Para além daquilo que é o substrato, porque nós, por exemplo, temos casos concretos em que vamos atravessar uma zona pantanosa. Se atravessarmos uma zona pantanosa, quanto maior for o aterro, em termos de altura, para além de ser maior o peso e o esforço no assentamento, também temos o risco de ter muita pressão hidrostática na lateral se houver uma cheia. E mostraram muito bem o caso da estrada Chissaro-Chibuto. O primeiro projeto de reabilitação, 2004-2005, foi feito por nós. E, com muita altura, secções completas falharam. Eu acho que a recomendação de baixar a plataforma, eventualmente, a parte ambiental pode ou não solicitar o aumento ou diminuição do número de passagens hidráulicas, porque um caso concreto que nós temos, a estrada para Macaneta com 8 km tem 43 passagens hidráulicas, espaçadas em cerca de 230 metros cada, mas já há alguns agricultores que reclamaram a possível entrada de águas com salinidade do lado do rio, quando há essa entrada, para o lado das plantações. Então, estava-se a pensar em ir para o lado da entrada d'água algumas comportas, porque já gerou, para além de ter melhorado a drenagem, gerou ou está a gerar em alguma secção pequena um ligeiro problema ambiental. Obrigado.
Obrigado. Engenheiro Cremildo?
Sim, obrigado. Tenho um comentário. É o seguinte, esta questão de drenagem realmente é uma questão muito importante para as nossas estradas. Mas recordo-me que temos um estudo desenvolvido pela FINOC, que tem a ver com estudos sobre resiliência climática, e foram feitos alguns mapeamentos na nossa rede viária, zonas suscetíveis a inundações e outros efeitos climáticos. Sendo que está-se a falar de drenagem, eu acredito que seria importante ter em consideração, digamos, esses estudos, que é para se trazer, digamos, soluções concretas para casos concretos. Obrigado.
Obrigado. Bom, não vejo mais ninguém a pedir a palavra. Só para tranquilizar os colegas, o grande problema que se tem aqui da resiliência climática não tem muito a ver com a qualidade de design que a gente tem. Se olhar para os manuais que falam das pontes, por exemplo, como ele disse muito bem, vão te dizer que é preciso colocar um freeboard de 1.5, 0.5 até 1.5. O grande problema que se coloca aqui é este 1.5 ou 0.5 é definido em função do histórico que tem acontecido nos últimos 50, 100 anos. Mas o grande problema que estamos a ter agora é que os eventos que estão a acontecer nunca aconteceram. Ok? Então, isto é como os aviões. Eu ando muito do avião, tem aquelas máscaras que põem ali nos aviões. Se houver baixa pressão, vai usar, mas provavelmente são dispositivos que às vezes são construídos 200 aviões, nenhum deles funciona durante o período de vida daqueles 200 aviões. O grande problema da resiliência é, ok, fazemos o dimensionamento corretamente, tudo bem. Agora, temos que pensar se acontecer algo que não esteja previsto, como é que isto vai se comportar? Este é que é o grande problema. Este é o grande problema. Por exemplo, se nós colocamos o tal freeboard de 1.5 e se tivermos uma cheia que ultrapasse os 1.5, o que é que vai acontecer com a estrutura? Esse é que é o grande problema. Temos alguns dispositivos que vão permitir que a ponte se mantenha lá, intacta, e aguentar as cargas que ela há de ter, horizontais que ela há de ter ou não. Este é que é o grande problema. Não é muito problema do design. As pessoas erraram, não é por aí. É ter outras considerações que não têm nada a ver com design. Pensamento só. O que é que pode vir a acontecer se este nível que nós dimensionamos aqui for ultrapassado? Este é o grande problema. Em relação a esta questão este exemplo que o engenheiro Celso deu é um exemplo muito, muito interessante. Eles fizeram essa estrada de Chissano-Chibuto e depois vieram as cheias de 2012, 2013 e a estrada sofreu um washout. A solução que nós encontramos foi mesmo de baixar o nível da estrada. Porque as consequências que nós podíamos ter se tivéssemos elevado no nível da estrada eram catastróficas, seriam catastróficas. É que se o nível de água subir naquele ponto por onde passa a estrada 50 centímetros para cima do nível da estrada, a cidade de Choca toda já não existe. Então, não é só o problema de pensarmos naquele ponto onde a gente está a construir a estrada. Temos que pensar nos efeitos que esta medida pode trazer para o ambiente todo. O engenheiro Dadi andou naquela estrada, eles é que fizeram os levantamentos, eles é que tomaram a decisão de baixar o nível da estrada. Porque, de facto, seria um desastre elevar o nível daquela estrada e traria problemas muito sérios para todas as populações que vivem a montante da estrada. Então, são estes aspectos que nós temos que começar a pensar neles quando estivermos a fazer o dimensionamento tanto das estruturas hidráulicas, assim como dos nossos pavimentos. E se houver uma situação acima destes cálculos que todos nós estamos a fazer. Como é que a estrada vai se comportar? E quais são os mecanismos que a gente está a criar para que, se isso acontecer, a estrada não tenha assim problemas graves? Porque alguns problemas sempre vão existir, mas é reduzir o nível de gravidade dos problemas que podem lá acontecer. Isto é que se chama resiliência. É por isso que nós temos estado a dizer, o problema da resiliência não é o problema dos ambientalistas. O problema da resiliência das estradas é um problema dos engenheiros, porque os engenheiros é que têm que encontrar as soluções adequadas para que a estrada ou a estrutura possa resistir a esses eventos. Penso que não há mais nenhuma pergunta. Eu levantei esta questão porque, geralmente, quando há fóruns de discussão de assuntos sobre mudanças climáticas, os engenheiros não estão lá. Ou os engenheiros nem sequer são convidados. A gente pensa, isto é pessoal do meio ambiente. Mas estas mudanças climáticas trazem muitos desafios para nós como engenheiros. E temos que estar lá e atentos para ouvir o que é que o mundo nos traz, para nós podermos atempadamente encontrarmos soluções que possam inverter a situação em caso de ocorrência dessas situações. Penso que já não há mais nenhum pedido de palavra. A única coisa que me resta é agradecer a apresentação, agradecer o apresentador.
Can I just say one thing in here? When we talk about resilience, we are talking here about physical resilience, but resilience is organizational resilience, and then capacity resilience as well. If your road breaches, how quickly can you fix it back in place and make it that road operational? So when you take, today we are talking about infrastructure resilience, but we need also to think about organizational resilience and capacity resilience as well. Thank you.
Obrigado. Vou convidar o próximo apresentador.
Okay, thank you very much. On the program, the rationalization of designs was programmed for about 1 hour, but you will probably be glad to know that it will not take that long. But it's nevertheless a very important activity which we all have to undertake after we have done our pavement designs. So in the morning, we had done examples of pavement design. And then after the lunch, my colleague who has just presented talked about certain measures to be undertaken to ensure that the pavements we design are resilient to the effects of climate. Now, all of this plus other things, after you've selected your pavement structure, you have to use to modify the pavement structure that you've selected. And that is what rationalization of design is all about. There could be a better word than the word rationalization that applies, but at the moment I'm not aware. But simply put, rationalization is making your design practical. Design as practical, that has considered your local conditions and local resources. So I think I've got about 15 or less slides to show regarding rationalization. So you can generate several pavement design options. In fact, I think most roads agencies require that a consultant generates several options, and then based on those options, they have to recommend what their final design is. Now, this means that after you have done these designs, you actually have to upgrade some of them, or you have to downgrade some of them. And we shall soon discuss what that means, upgrading or downgrading. You will also be required to carry out an economic analysis. These days, you cannot survive without carrying out an economic analysis, especially when the project will be funded by loans borrowed from various agencies or even from the central bank of the country. There will also be what I've termed ancillary considerations. Some of these ancillary considerations include acceptability of the solutions you are proposing by the local community. In some parts of the world, surface dressing can cause a lot of trouble with different communities. They will not accept. They will say, we saw an asphalt concrete on the other road in a certain district, and that is what we want here. We are not going to accept surface dressing. So there'll be such ancillary considerations. Now, all of these things can actually lead you back to redesigning. So you go back and have to redesign because certain factors have forced you to make changes. So the first is the enhancements that are required for climate resilience. So you finish designing your structure and you now ask yourself, okay, what am I going to do to make my road climate resilient? Many agencies now require that you demonstrate that in design. And as my colleague said, you have to identify critical sections of the road that could be affected by climate change effects or climatic effects. You have to know where overtopping is likely to occur, where capillary rise is likely to occur. And for the case of asphalt surfacings, you have to identify which sections of your road are likely to result in low truck speeds. Because when trucks travel slowly, especially when they're going uphill, they're going to stress your asphalt more, it will deform more, it will fail quicker, and you can decide that such sections should actually be built with rigid pavements rather than with flexible because of these kind of things. So immediately your design has to be revised just on that basis. Then we have recommended some climate resilience solutions in Chapter 6 and Chapter 7 of the road note. Chapter 7 is what my colleague has just presented, such as the embankment protection, barriers of capillary rise in areas prone to ponding by the sides of the embankments of the road, subsurface drainage, which most times people forget until the road is built, then they see and say, oh, we should have put a subsurface drain here. So a good designer is supposed to anticipate where they need subsurface draining. Sometimes you may actually have to again work with the geometric designer to change even the vertical alignment of the road, not just the horizontal alignment. You may say, no, I'm going through a lot of cut, or I'm going through a lot of fill, and I need a change here because of various things. Now, the second major area where you have to think about to rationalize your design is technology considerations. You need to ask yourself, can materials be achieved to the specified quality if I specify stone mastic asphalt in an area where they've never built a stone mastic asphalt? I need to ask myself, do they really have the capacity to build this accurately? I also need to ask, for example, in areas where you may propose that they recycle some asphalt from somewhere into the new asphalt, or where you may recommend a bitumen or emulsion stabilized layer in your structure, you may have to ask, is that technology actually available in that part of the world you're working in? And this may require you to either change your specification to accommodate some weaknesses or some strengths, or you have to do some compensation by saying, okay, instead of specifying a CB1, rather CB3, I'm going to specify CB2. Instead of specifying a granular material of quality 3, I'm going to specify quality 1, because you're trying to compensate for some inadequacies, maybe in supervision or in construction quality. Now, I know at the moment, many projects still do not consider carbon footprint. But in the coming years, some donors will actually ask you to demonstrate that the technology or the structure you've chosen is of a lower carbon footprint than others that you had considered. Anyway, but we have initiated that by including the carbon footprints of various materials in Chapter 13. But the subject can be very complicated because you have to consider it in life cycle terms, not just today. You have to consider that if I put this material down today, which has a low carbon footprint, will I need to replace it every 5 years compared to one with a high carbon footprint that I replace once in 40 years? And this comparison is very relevant between asphaltic concrete and cement concrete pavements. Still with technology considerations, you will learn, or you would have already learned, the preference of contractors within your country, your region. You may be dealing with contractors that, for example, in this case, they prefer certain layer thicknesses due to the ease of construction. For example, a contractor, as shown in this table here, they can prefer that instead of compacting 175 millimeters of a certain granular material, they are more comfortable actually compacting 300 in 2 layers, and then in the lower layer, instead of compacting 2 layers, they compact 1 layer. So they may find it easier, to deal with that granular material than to deal with the cement-bound material. So in this case, I would say, instead of me working with 200 millimeters of cement-bound material, I want to work with 150, and I work more on a granular material because it's easier to compact. So that discussion during the design review can force you to change the initial design that you had actually decided to go ahead with. So you should be prepared. And in chapter 8 of RN31, we have these conversions based on structural number. You can also engage in mechanistic empirical analysis rather than structural number, and you see what thicknesses of the various materials are appropriate for what the contractor is proposing. Then this alone can actually lead you to do some special specifications rather than the specifications contained in your standard specifications for road and bridge works. You may have to devise your own special spec because of what you're recommending. So you need to be aware of this, and you should be prepared to make revisions based on these things. You should also do sometimes redesign considerations. For example, subgrade replacement. You can be in an area where you have material which is of quite good quality close by, and yet you have very poor subgrades. So in that case, you can say, actually, all the subgrades measured in my alignment are not suitable. I'm going to cut them all out and import this material here, which means you actually do a new design consideration. Or you can say, I've got weak subgrades, but I've got plenty of lime or cement. We'll treat these and improve their strength rather than bringing in fresh capping. There could also be material taken out of another road somewhere because it's unsuitable for those layers. But those materials can be suitable for the lower pavement layers in your new project road. So you should also make such considerations and say, we're going to use this material from the other project, and that means a redesign as well. Now, don't forget, or let us not forget, the use of geosynthetics, especially in improving subgrade strength. I know that acceptability of geosynthetics is still not very widely acceptable, but there are some good quality ones out there that actually work. They have been there even for several years. So such considerations should be made. The use of rock fill and filter mattresses, as my colleague talked about, to enhance drainage. You may say, this area here, we have to enhance the drainage using rock fill or filter mattresses. So all those start affecting whatever you have designed. And actually, I think is the part which consumes the engineer's time the most. These little things, making these changes rather than deciding a structure. You also have to develop the standard specifications that apply to your project, because you're not simply going to lift that document with the standard specification for road and bridge works and say to the contractor, here you go, find it in there. He or she can pick a different part of the spec that doesn't apply to your project. So you have to again go to the standard specification, pick out the tables, the specs that particularly apply to your project or to your design. We have in the Road Note 31 the specifications for unbound in Chapter 4, bound materials Chapter 5, and bituminous mixtures in Chapter 6. These can be different, could be different to your national specifications. So you may have to seek permission if you're deviating from your national specifications as to get this approved before you send it off to the project. It involves selection of various nominal sizes, like for example in this table. In the catalog, in the design catalog, you find we've said GB1. Now you come here, you find that there are actually several distributions of GB1. So it means you have to be aware of your local context. What does the local crushing plant produce? Do they produce the 28 millimeter, the 37.5, or the 20? Such kinds of considerations. In the morning, I talked about rut resistance, areas where there are slow-moving trucks, such as climbing lanes. The need to mitigate the stresses induced by super single tires. Solutions are provided in the Road Note 31. The need for design for durability as well is also provided. Now, we also have improving asphalt performance. Other than the standard, other than the common spec that is provided, there are also additional ways of improving the performance. You can choose to substitute the types of binders that you're going to use. You can say, we need to use polymer modified binders here to reduce the onset of cracking, reduce rutting. You can also use epoxy modified binders to enhance the resilience of your surfacing. You can introduce or specify the need to use adhesion agents, reduce binder stripping. You can introduce wheel tracking specifications to minimize rutting. So they're all these things that are necessary to rationalize your design. There's also improving overall pavement performance. As I mentioned, the use of geogrids at appropriate locations, the use of drainage layers, my colleague talked about, emphasis on good shoulders. The last one, contractors hate this one because if you're using different camber at different layers, you have to set up string lines all the time. You're changing from one layer to another to get the camber correct. But it's very helpful in subsurface drainage, especially if the subgrade is made up of poor quality expansive material, for instance. Now, maintenance planning should be included in design, and documentation should be included in that respect, because there are several situations that affect the design that comes out, one of which is the budget. You may only have a budget that's available for a design period of 10 years. And after that, an overlay is required. So if this is not documented in your design, and year 12 comes and somebody says, this road was designed for 20 years and it's now falling apart, they don't realize that there was an overlay supposed to happen in year 10. So this should be captured and shared with the planning department that exists in your agency. Okay, I mentioned about budget. Now, the cost, in some cases, you can find that the cost estimate of the final technical choice could be higher than the budget. In fact, in most cases, what you choose will be higher than what the available budget is. There you have to consider stage construction, or you have to consider shorter design life, or change your technical choice. For example, go for a thin bituminous seal instead of asphalt. Then the very, very rare case where your design choice is actually costing lower than the available budget, very rare case. That gives you the opportunity to enhance the solution that you've provided. For example, you can decide now to go for a polymer modified bitumen instead of a standard grade, penetration grade bitumen. You can also choose now to use superior materials to what you had designed. But remember that you still have to do an economic analysis using tools like HDM4 or other similar to justify the economic viability of your project. So in conclusion, in area of rationalization, pavement designs will often change from the initial catalog selections due to the rationalization measures. The catalog is just giving you a starting point to have a comparison with other technologies, other structures. After that, things can quickly change. You would have the opportunity at rationalization to upgrade and add protective measures to your design. In some cases, you'll be required to downgrade your design, which means you're told the budget's not available, you have to do something else, which is less. And now, of course, as an engineer, you're supposed to document all of these key decisions very, very clearly. And you should seek a deviation from standards if required, because people have short memories. Somebody will not remember telling you to use or to downgrade your design if you have not documented all the decisions that led to your final choice. In most cases, the national or the agency specifications will override other specifications, which means if you see a specification in Road Note 31, in most cases, your national specifications here in Mozambique will be the legal specification that you're supposed to use, especially if it's been signed by the minister that this is the document that applies to Mozambique. And if you find economic benefit in deviating from this specification and using, for example, the one in Road Note 31, you then have to seek for that deviation in the standard and state why it's beneficial. And I think in the Mozambique manuals, there is a form in every manual that you can fill in to deviate from what the manual and standard specifications say. So that process is already there. I think that was all on the rationalization of design. Thank you.
Obrigado. Colegas, temos mais uma apresentação por ser feita. Não sei qual é a melhor abordagem que devemos fazer. Podemos ir para a próxima apresentação, depois vamos à sessão de perguntas, comentários. Podemos proceder dessa maneira? Ok, tá bom, obrigado.
Okay. The next presentation is really a demonstration of the example that we did in the morning by simply using a spreadsheet and hopefully I'll try and go a bit deeper into this spreadsheet and So I've got what initially appears to be a very scary spreadsheet, but it's actually very, very simple because you don't have to use all of the tabs. Basically, it's giving you flexibility on how to deal with certain things. And I'll just run through and then demonstrate how we could have used it to do the example we did in the morning. It applies at various stages depending on the kind of data you have and or don't have. For example, the first tab is if you're starting off a design where you've been given the average daily traffic and you have also been given raw axle loads. How do you convert this into MESA, for example? So sometimes that can be the case where you're actually provided some of this information. For example, they may give you the flow in each direction. Say direction 1, the flow is this. Direction 2, the flow is that. Then they give you some factors like the lane distribution factor, which means if it's a multi-lane, how much traffic each lane is going to carry. They can also give you a seasonal factor and say that this traffic was counted in August, and to get the annual average in August, you have to multiply by 1.2 or 0 point something. Usually, the planning departments have these factors. Then they may also tell you that if your project goes ahead, the diverted traffic will be 20% of the normal. The generated traffic is going to be 10% of the normal. And you can now just punch in these factors when you're given, plus the ADT of each vehicle type you punch in. And the spreadsheet is going to use this to be able to calculate the MESA, which you use for designs. So usually when you're given such data, they'll also give you axle load counts, where they say we counted 50 vehicles, and this is the result. So you find vehicle 1, axle 1, the load was this, vehicle 2, or second axle was this load, and so on. So it becomes a bit tedious, but here you can just paste in the axle loads of the various vehicles that you've counted. And using this spreadsheet now, the spreadsheet will get the ADT of each of the vehicle classes you're considering. It will also get the equivalence factor of each of the vehicles and then calculate what it is per day. And given various growth rate periods, it will calculate for you the MESA. So you can say period 1 is 5 years, period 2 is 10 years, last one's 5 years. You put in this information and it helps you to calculate the MESA. It's based on the formulae which are in the road note 31, so that if you don't want to sweat doing it manually, at least the spreadsheet helps you. But there's also an option where you already have been given the design MESA by some department. So you just come in here for direction 1 and you punch it in, because you've got it from a certain software, so you just come and punch it in there. The same thing applies for direction 2. And in this tab of number 7, there is a more complicated way of doing what I just explained. In this case now, you are counting your vehicles in a different way. You're counting even those that have super single tires, those that are running the super singles, and you want to take into account different standard axle loads and all of that if you want to go that route rather than the basic that we're used to. There are also these options, and it does the same thing. calculates, you enter your period, then it calculates for you the MESA that is there. The same thing applies for direction, the second direction, and eventually it calculates for you the design MESA. So that is just on traffic. Then you come to subgrades. This is just a carbon copy of what we have done in the morning, how to compute the cumulative sums. So you put in your chain edges and your CBR values, and it computes for you the, it helps you identify the uniform sections. And then you lift each uniform section here, and the spreadsheet now gives you the structures that are available for that traffic level. You could also skip all of that we've discussed before and just come and put what your subgrade strength is if you already know it from another place, and then punch in the value of where you want it to be and get the structure that applies. So it's just a flexible system, but I'll demonstrate it for the morning case that we did. So I will come to, let me say that the 51 measure that we used was for direction 1, and we've got this value from somewhere. So I'll come here where it says if the measure is already known, and I'll put 51 here. Now, after that, I'm now going to my subgrades to try and get my uniform sections. And allow me to copy from the previous spreadsheet, which is this one. Okay, I can come and copy these values. Copy here. Then I'll paste them here. And then it is automatically producing a graph similar to the one we saw in the morning. I just pasted the values there and it's produced that graph. And I can now define my uniform sections. So I remember from the first one, I'd chosen that the first section is at up to 6.5. So I now take my values of the CBRs up to 6.5. I copy this, go to the next sheet, and paste it there. It's also good practice to take the chain edges. So I paste this there. I'm using the 5th percentile as in the morning. And you can see that it has picked out that the CBR here in this cell, the subgrade CBR for this section is 6, and it is S3, the subgrade class. And if we compare with the one we did in the morning, you can also see here that is CBR 6 and the class S3. Now with that done, I now select what I wanted to design in the morning, where we said equivalent to S4 from this drop down. So if I click there, equivalent to S4. Okay, I'll scroll here. And you can see that the 51, which I entered somewhere before, has come here. And the traffic class is T10. It has given me the capping option and said use 150 of GC. GC is CBR 15. And it has gone and looked and found that I can use two catalogs in the RN31. The one in C2, catalog C2, means I put a wearing cost of 50 on 60, on 175, on 250. which was what we found in the morning. And there's another option with a different catalog which uses different thicknesses. Now, so this is, you can do this, but remember that if you do this, you would have skipped a lot of the information contained in the Road Note 31. So you should only really use it after you've first read the Road Note 31 and you know what you're doing. Like with all tools, you know what you're doing. And then after doing this, of course, just like I said, when you do the rationalization, you'll start making changes to these proposals and say, okay, I'm changing this because of this, I'm changing that because of that, and you come back to what I previously just explained. So for now, I will stop here and will not do the concrete part, the rigid pavement part, because my colleague Nigel will do that tomorrow to show his own version, I think, of the spreadsheet for dealing with rigid pavements. But his version will rely on the fact that you would have entered the traffic information, that you would have entered the traffic information, axoload information rather, axoload information accurately from such a spreadsheet, and then you go to his. Process is very simple. You can copy and paste into it or fill it in manually, and then it does the rest for you. Like with all spreadsheets, you'll never find two individuals who produce the same spreadsheet for the same problem. Everyone will have their own preferences. So we've left this open for, we've not locked the cells so that people can change it to what they prefer. And I think that is all for now.
Obrigado, Andrew. Colegas, tivemos estas duas apresentações, a racionalização e o spreadsheet, que nos ajuda a fazer os cálculos que nos foram mostrados no período da manhã. Está aberto o espaço para comentários, perguntas, se houverem, por favor. Sim, engenheiro Celso.
Sim, boa tarde. Andrew, when we talk about traffic counts and axle load survey, we normally have some many rules which we have to do the traffic counts for a week with, let's say, 7 days, 2 nights. But my main issue is normally statistical considerations on the axle load survey, we still rely in many of the cases on the road note 40, which gives you that if you have traffic until 60 trucks, you can measure, let's say, 40 trucks. If you have 100, you can measure another 30 or 40, and this kind of things. But the road note 40, the last version which we have here available on site is from 2004. Are you telling me that some of the, let's say, upgrades and considerations on the road note 31 will overlap or overtake all the considerations on road note 40? That's the first question. The second is, that's true. When we do a tender and go for a specific contract, you have to go to site and do the traffic survey after the consignation. Sometimes are in April, other times are in September, can also come to you in December, January. There is factors to correct the axle load of this traffic survey during the year, because I do believe that Sui Road did some of these tables, which we call it annual variation. But I don't know since when those tables are, or this table are not, let's say, updated, because the last version which I have is from 97 maybe, and it is for the province. Every province, when you do the traffic counts, you need to try to multiply by the coefficient. There is any updated study for these variations? Thank you.
Okay, so, sorry? Okay, thank you very much, Engineer Celso. Those are actually very, very pertinent questions, very relevant and key. Road Note 40, I think, Nigel, were you not the author?
That was one of them, yes.
The author is here. So one of the authors is here, so you should answer this. But certainly, the recommendation in Road Note 40, there are a lot of recommendations inside there, some of which are still very valid. And the ones we're making in Road Note 31 now cannot actually cover all of those recommendations, because we are trying to focus mostly on the pavement design, and we cannot dive too deep into these recommendations, but they are really still valid, like doing the 7 days minimum. Some of those statistical sampling sizes still apply, because ever since people, okay, at least on our side, research hasn't been done on those statistical sample sizes, which are quite relevant, I think, still up to now. And then where the Road Note 31 may supersede what is recommended in Road Note 40 is on the issues of the damage exponent. We cannot continue to use only a single value. We have to deviate from that. And particularly for the design of the rigid pavements, which we shall see tomorrow, the method we have adopted requires the axle loads to be measured in a certain way, which means you actually have to consider axle load groups, not single axles. Now, I think I was given some data from one of the way bridges here in Mozambique, which captures the data in that way in terms of axle load groups. So that can actually be a very good source of that information already to capture in load groups. And many other countries have similar way bridges that capture in axle load groups. So I think that those two in particular would override what's in Road Note 40, but the statistical aspects, I think Road Note 40 is still valid on that, because we haven't recommended sampling sizes for these in Road Note 31. Engineer Kalada said he will respond to the second question, so I'll pass that to him.
Yeah, obrigado, Engenheiro Celso. Nós estamos a atualizar os fatores, sim. Provavelmente o que pode estar a acontecer é que teve aquele spreadsheet nos tempos passados e nunca mais passou da ANE para ver o que é que está sendo feito. Na verdade, o engenheiro Lionel está a trabalhar nisso, e acho que foi há 2 anos que você fez a atualização, não é? Yeah, ele fez a atualização já há 2 anos daqueles fatores. Não são fatores estáticos, são fatores que estamos a trabalhar neles, e à medida que a gente vê que a situação está a mudar, nós fazemos a atualização. Obrigado. Mais comentários? Questões? Já estamos cansados, não é? Andrew, penso que já não mais há nenhum comentário, nenhuma pergunta pode tomar o seu lugar.
Okay, just to make a quick statement, the quality of the print of the document that you have is not very good, but we have provided an electronic version, which is quite heavy in size. It's not really emailable, but I hope it gets to you. However, I caution that in maybe a month or two, you visit our website, and I'll also share with you a link so that you download what is the definitive version, where minor errors would have been corrected and some things would have been corrected. And periodically, you have to keep checking the site so that you have access to the real latest version. There'll be minor changes, not major changes. Thank you.
Obrigado, Andrew. Colegas, penso que chegamos no final dos nossos trabalhos deste primeiro dia. E acredito que foi um dia útil, onde tivemos a oportunidade de partilhar esta nova versão desta nota rodoviária 31, e que acredito que vai nos ajudar bastante nas nossas atividades do dia a dia, como planificadores, como projetistas, como executores das obras das nossas estradas. Como o Andrew disse, temos a versão eletrônica para quem quiser, e porque sei que muitos de vós trouxeram computadores, pode copiar esta versão para não esperar por um mês e começarmos desde já a ler e perceber com detalhe quais são os novos acréscimos ou os updates que foram feitos na nota rodoviária 31. Por hoje vamos terminar por aqui, na esperança de voltar-vos a ver amanhã às 8h30. Sim, amanhã às 8h30. A sessão de amanhã estará mais focada para pavimentos rígidos e, como eu disse no período da manhã, não são pavimentos muito comuns aqui em Moçambique, mas tudo indica que nos próximos anos vamos ter que caminhar para este tipo de pavimentos, porque as nossas estradas estão a ter uma sobrecarga muito elevada e que vai obrigar para que a gente recorra a este tipo de pavimentos para podermos ter pavimentos com uma vida longa e com uma durabilidade aceitável. Tendo dito isto, Declaro encerrada a reunião, o workshop para o dia de hoje e até amanhã às 8h30. Obrigado. Obrigado. Arigato.